Before we start using Docker Compose, let's first create a new directory where we can place the Compose YAML file and any future infrastructure-related files. So here I am in a new Visual Studio Code instance. I have opened my terminal and I am switched into the projects directory. So in this directory, I'm going to create a new folder. I'm going to call it play.infra. And now I'm going to open it in the Visual Studio Code. And the first thing that I'd like to do here is to take advantage of the another extension for Visual Studio Code, which is the Docker extension, which we can find if we go to extensions. Let's just type Docker. This one here, because this one is going to provide us some good recommendations as we start working in our Docker Compose file. So I'm going to install this extension, click install, and that will show up a new icon on the left side, Docker. So let's close this and let's go back to our Explorer. Now what we can do is just go back here and let's create a new file. Let's call it docker compose.yaml. And before writing any code here, what I'd like to do is to bring in that previous docker run command line that we've been using, just to keep it as a reference as we start writing this Docker Compose file. Okay, so remember this line that I just pasted. This is what we've been using so far to kick off our Mongo container. So the first thing that I want to do in this Docker Compose file is to define a version for it. The version determines what features you're going to have available in Docker Compose, because different versions of the Docker Compose engine support different versions. So you have to define what version is this file for. So I'll say version. It's going to be 3.8 is the latest one available as I'm recording this lesson. And the next section is what we call services. The services will determine, each of these services is really one of our Docker containers. So I'll define a services section. And under services, you want to define our first service, which is, in our case, is going to be MongoDB. So I'll just name it Mongo. And as I start writing this, notice the indentation that I'm setting between each of these elements. Indentation is important because it defines which elements go inside other elements. But to make this more easier to see for you, what I'll do is I'll enable another setting in Visual Studio Code so we can see the white spaces that are happening across the place. So I'll go to File, Preferences, Settings, and I'll look for Render White Space. Yeah, so it's this one here. So I'll switch from Selection into All. Then I'll close this. And now we can see the white space right there. Yeah, so as you work on this file, just make sure that you're leaving the same amount of white spaces or indentation with the different elements that we're going to write. I will also collapse this left side, the navigation pane, since we don't need it for now, so we can have more space. So inside the Mongo element, we're going to open yet another element. We have to define the properties for this service. So first thing we're going to define is the image. And as you remember from the command line on the top, the image is Mongo. So I'll grab that. Then we have to give a name to this container. So the container is going to start up. So I'll say container name, and the name that we've been giving over here is Mongo. So let's use the same name. It's going to be Mongo. The next thing is the ports. So ports is actually an array of ports. So the array you can define by placing a dash first, and then you specify the port mapping. So I'll grab that port mapping from here. As you remember, port is 27017, external port on the left side, internal port on the right side. And the next thing that we have to define is a section for our volumes, because remember that we need to map the /data/db directory inside the MongoDB container into a location outside of the host where the files are actually going to be written. That's what we call a volume. So to define volumes, I'm going to go all the way here at the same level as our services section over there. Here we're going to declare a section called volumes. And under volumes, I'm going to define our MongoDB data section, which I'm actually going to copy over here. MongoDB data column. And that's really all you have to do to define one volume. in your machine. And now we have to associate that volume to our Mongo service over there. So I'm going to open yet another section here called volumes under ports. And under volumes, you have to define an array of all the volumes that you want for this service. So an array starts with dash, and then you define that volume mapping. So I'm going to copy this again. There. So that defines so /data/db is mapped into MongoDB data. Remember that we have to do this because otherwise our database files will be lost if we restart the container. So from here on, anytime that the MongoDB container tries to write to /data/db, those files are actually going to be written into the MongoDB data volume that's outside of the container and into our host machine. Okay, so now I'll save this file. And it's time to start running this container via Docker Compose. So I'll open my terminal, Ctrl-J. And the first thing I'd like to do here is make sure that I am not running MongoDB container already. So let's see, Docker PS. Docker PS. And so we are indeed running it already. We don't want to have it running there because that could cause conflicts. So I'll just go ahead and stop it. Docker stop Mongo. Okay, and now it has been stopped. So with that done, we can go ahead and start our Docker container via Docker Compose, and we can do Docker Compose up, hit enter, and then that starts running the container. And what you're seeing now is just the output of the MongoDB container being generated directly into the terminal. So now that we have the Docker Compose running our MongoDB Docker container, let's see how is our catalog API working with this new way of running the container. So I'm going to go back to our catalog microservice, and I'm just going to hit F5 to get things started. Okay, with the host up and running, let's go ahead and open Postman, and let's go ahead and try to get all of items in the database. So here I am in my get operation for the REST API. So I'll hit send. And interestingly, I'm not getting any items, which is interesting because as per our previous lessons, we did have at least one item already stored in the database. So what's going on? Let's see, let's go back quickly to Visual Studio Code, catalog, and let's explore our database at this point in time. So I'll collapse this a little bit, and let's go to the MongoDB extension, and here's our localhost 27017. I'll connect to it, and the interesting piece here, and I'll collapse these other pieces, is that we don't have a catalog database anymore. And this is happening because as we moved into Docker Compose, a new volume has been created for our database files. So technically, this is a brand new database, which has no items yet, right? So there's actually nothing in there, so there has not been any need to create a database yet. So that's why you don't see any database here. So just keep that in mind as you switch from a raw Docker execution into Docker Compose, a new volume will be created. So let's actually come up with something for our catalog database. So I'll go back to Postman, and I'll go to my Post tab, body. Okay, and so let's again define something here. We'll go again to our potion example. So it's a potion, and it stores a small amount of HP, and the price is going to be just 5. So go ahead and send this, and the item has been created. So if we go back to our get items API once again, hit send, the item is there. And if we go back to Visual Studio Code to catalog and we refresh this, you can see that now we have our catalog database with our items collection and the one document already created in there. And one last tip that I want to give you as you start working with Docker Compose is how to prevent, let me actually open Docker Compose, how to prevent all this output to be shown here. So in case that you don't want to see all this output from the database all the time, you can see things in a much cleaner way by doing the following. So I'll go back here to my terminal. I'll just hit Control-C to stop Docker Compose. And what you can do is you can do Docker Compose up, but you can append the -d parameter to run in detached mode. So if I do enter now, the only thing that you're going to see is that it's starting Mongo, and then it says done. So the container is running in the background, but you don't have to be looking at all the output all the time. So it's running in a detached mode. And still, if you go back to Postman and you query, you can see that the container is actually running. So we have reached the end of this module with a few improvements to our developer workflow and with a reusable library that will speed up the construction of our future microservices. In the next module, we will introduce our second microservice, and we will learn about the multiple challenges of having microservices talk to each other. In this module, you will learn about the different microservice communication styles, and then you will learn about a few techniques to properly implement synchronous inter-service communication between the existing catalog service and a new inventory service. By the end of this module, you will have a solid understanding of the following: the different microservice communication styles, how to implement synchronous communication between two services via REST and the HTTP protocol, what kind of partial failures could impact your microservices and why you should design for them, how to set timeouts to fail fast when doing inter-service communication, what is and how to implement the retries with exponential backoff technique, and when to use and how to implement the circuit breaker pattern. In terms of our overall system design, in this module you will build your second microservice, the inventory service, which owns the player's inventory back. We will use everything we learned in previous lessons and our reusable common library to build this new microservice much faster than when we built our first service. Then we will let inventory talk to catalog synchronously using several techniques for resilient communication. Let's move on to the first lesson. In this lesson, we will create our inventory microservice, which owns the player's inventory of purchased items. Just like we did with the catalog service, we will define a REST API for inventory with a couple of operations, which are post items, which will be used to add an item to the player's inventory bag, and get items by user ID, which should retrieve all the items for the specified player or user. Talking about users, you may have noticed that we have not properly introduced the concept of players or in general users into our system. This is fine. The management of the actual users database will be the responsibility of the identity service, which we will create in a future module, along with all the microservices security infrastructure. For now, we will use random GUIDs to identify the users that own the inventory items. Let's get started. It's time to spin up a new project for our inventory microservice. The process is exactly the same as we did with our catalog microservice, but this time, to make things quicker, we won't create it from scratch, but instead we will use the starter project files I have attached to this lesson in the play.inventory.start zip file just under this video. Please download the zip file and extract it into a location in your box. In my case, I have already downloaded the file into my projects directory, as you can see. It's right here. So I'm going to go ahead and just extract the files. File contents, I'll just extract. So it's right here. So I'm going to delete the zip file. And I'm just going to rename this directory as play.inventory. So this one here, from here on, is going to become our starter inventory microservice. So having done that, what I'm going to do is just go back into Visual Studio Code over here. So this is a new instance of Visual Studio Code where I'm going to open up that folder that we just extracted. So I'm going to click on File, Open Folder, and I'm going to go into my D drive and Projects directory. I'll pick Play.inventory, and I'll click on Select Folder. So now Visual Studio Code has opened in the context of the Play.inventory directory. Now right away, Visual Studio Code wants to restore the dependencies of the projects included in this directory. So I'll just click on Restore. and that will bring back any missing dependencies of the project. Now you may wonder what is different here as compared to the catalog microservice. Well, really, there's not much difference. One difference would be, of course, let me close this, the namespaces used here. So because everything is now play.inventory, something, right? But really the main difference you're going to find is in the, if you go to properties, launch settings.json file. Remember that this is the file where we define a bunch of things, but the main thing is the ports that are going to be used by the application. And so in this case, what we have is a different set of ports for this microservice. So if you see here, the application URL is now in port 5005 for HTTPS and port 5004 for HTTP, okay, which is different from ports 5001 and 5000 that we're using for the catalog microservice. You have to make sure that you never reuse the same ports for different microservices, because that's just not going to work in your own box. Right, and now that we have that, what we want to do is start moving on with the additional files needed in our inventory microservice. So what I'm going to do is just go into the play.inventory.service folder over here, and I right-click over there, and I'll just say new file, and we're going to name this file dtos.cs. Here I'll declare our namespace. The namespace is going to be play.inventory.service.dtos. And so we're going to define two DTOs at this point. The first one is going to be the DTO used to grant items to a user, and the other one is going to be the DTO used to return the series of items that a user already has in their inventory. So let's start by defining public record grant items DTO. And to grant an item to a user, we obviously need to specify the ID of the user. So it's going to be a GUID user ID. Let's add the system namespace there. We also have to specify which is the item, the catalog item that's going to be assigned. So we will define that as catalog item ID. And lastly, we have to specify how much of the item is going to be assigned to the user. So that's going to be the quantity. Let's now define the other DTO as public record. This is going to be inventory item DTO. Like I said, this is the DTO used to return items, the items that are assigned to a user in the user's inventory. So for this, we're going to be returning the catalog item ID, the quantity, and also let's define the acquired date. So this is the date when the item was put into the user's inventory. So now that we have our DTOs, it is time to start defining the entities that we're going to be using to store the inventory items into the database. However, before we can do that, we have to bring in our play.com NuGet package so that we can start using the bunch of classes and types that we have defined there, including our iItems, our iEntity interface. So to do that, I'll go ahead and do Ctrl-J to open my terminal, and I'll go to play.inventory service, and then I'll just do .NET add package play.common. Okay, so if we go now to play inventory service, we'll see that we have the NuGet package added here. Now we can go ahead and right-click in play inventory service, new folder, entities, and let's go ahead and define a new file. It's going to be inventory item.cs. Let's define our namespace. It's going to be play.inventory service entities. Let's define the class, public class inventory item. And let's make this class right away implement our iEntity interface. Let's make it use play.common namespace. And as we're implementing that interface, let's do Ctrl- implement interface. So we have to define a GUID. So public GUID ID. we'll make it define just a get. It will be just a get and set, just like that. Okay, so each inventory item will have an ID. Then it should know to which user it belongs to. So let's do prop GUID. It's going to be user ID. Next, let's define which catalog item this inventory item corresponds to, a reference to the catalog item. So it's going to be prop GUID catalog item ID. Next, we'll define the quantity. It's going to be the quantity, how much of this item we have. Let me also close this terminal now. And lastly, let's define the time of set. Is going to be the acquired date, the date when the item was assigned to the user in the inventory. Save that. And just like we did with catalog, let's define an extension method so that we can transform one of these inventory items into the inventory item DTO. So I go ahead to the root, play inventory service. I'll add a new file. I'll call it extensions. Let's add a namespace. Play that inventory, that service. And let's add public static class extensions. And let's define our method here. So public static is going to return an inventory item DTO. Let's call it as DTO. And let's import the missing namespace. And it is going to be extending inventory item. Inventory item. Let's import that. It's going to be the item. And here it is just about creating a brand new item DTO out of this item. So we will say return new inventory item DTO with item that catalog item ID, item dot quantity, and item dot acquired date. So that's all we have to do to transform the item entity into an item DTO. Now we can go ahead and create our controller. So let's go to the controllers folder, right click, new file. We'll name it items controller, just like we did in catalog. Let's define a namespace for it. Play inventory service controllers. It's going to be a public class items controller. And remember, each of our items controllers should be marked with the API controller attribute. It should derive from controller base. And it should define the base route that is going to be mapped to. So route, this route, just like with catalog, is also going to be items, just because it also manages items. So route items. So now we're going to need one class level variable here, which is going to be the repository that we're going to be using to store and retrieve items. So let's define a private read-only. It's going to be a repository of type inventory item. And let's just name it items repository. So let's import play common here. And let's import play inventory service entities. Let's also collapse this navigation pane for now, since we are not going to be using it for a bit. And now we have to do dependency injection to actually receive this items repository into the controller. So let's define a constructor. Okay, so this constructor is going to receive again our repository. So just copy that here, item repository, and let's assign it to our local instance, item repository. So now it's time to define our two operations. Remember, we need an operation to get all the items in the inventory and one operation to put an item or to create an item into the inventory. So let's start with the get operation. let's define that as public async task of action result, and this is going to be of an enumerable of inventory item DTO. And then we'll name it just getAsync, and the parameter is going to be the user ID. So we want to get all the items in a user's inventory. So we're going to receive GUID user ID. Okay, let's see, let's add any missing namespaces, reading tasks, systems collection generic, and service DTOs, and for the GUID using system. Let's also define the verb that is associated to this API, which is going to be HTTP GET. And so the way that this API is going to work, this operation is going to work, is we just need to go ahead and get all the items based on the user. So, but before we can do that, let's do a quick check. Let's make sure that this user ID is not empty. So if it is a GUID empty, we're going to return a bad request. Bad request, a simple validation in there. And so to get the items, we're going to do this. So we'll say, so the items is going to be, and we're going to open a braces here. We're going to do an async call to items repository, get all async. And here's where we can start using our expression, our filter based on an expression. So in this case, what we want to say is that we want to get any item where item.userID equals the user ID that we got as a parameter over here. Okay, so that's how we can filter items based on a user in this case. And then when we have that, we can do a select. Let's see if we're missing another namespace, system link, where we're going to specify that we want to take each of these items that we found in the database and transform them as into a DTO with our extension method. And finally, we'll go ahead and just say return the items. Let's also transform this. Let's wrap this into the OK, into the OK action result. And that's all we have to do. So that will return all the items in the user's inventory. The next method is the one that we're going to use to assign one item to the inventory. So this is going to be a post operation. So let's see. Let's define it as public async task. We will just do action result. We're not returning really anything out of this method. Going to be post async, and it's going to be receiving our grant items DTO. Items DTO. Let's mark this with the HTTP post verb. Here what we're going to do is we will try to find if we have that inventory item already assigned in the inventory, because it could already have it. So in which case we just need to increase the quantity, or in the other case where we don't have it, we just have to create it for the first time in the inventory. So let's try to find it. So we'll do, so it's going to be inventory item equals, oh wait, items repository, get async. And again, here's where we can use the expression filter, where we're going to say that the item that we're going to try to find has to be one where the item that user ID has to match the grant items DTO user ID. And also the item that catalog item ID has to match grant items DTO catalog item ID. Let me see if I can put this in the next line. So that will find the item if it is there. So, but if the inventory item happens to be null, this is the first time that we assign this item to the user. So in that case, we will go ahead and say inventory item equals new inventory item. And we will set its catalog item ID is grant items DTO that catalog item ID. The user ID is grant items DTO that user ID. The quantity is that quantity. And for acquired date, we will just set our current date time offset. So it's going to be date time offset that UTC now. And finally, we will call our method in items repository to create an item. So create a sync inventory item. Okay, let's add this missing semicolon there. And then let's go for the other branch. So else, we did find the item, so we just need to increase the quantity. So for that, we will do inventory item dot quantity plus equals grant items DTO dot quantity. And then we will do await items repository dot update async with the inventory item. And finally, we will just return OK. Yep. And that's pretty much for the controller operation. So we have two operations to retrieve the items in the inventory and to put an item into the inventory. So with that done, it is time to start doing the basic configuration of a startup. So I'll go back to our Explorer here. And first, let's go to app settings.json. Here we have to define the settings for our, in order to define the service name and the MongoDB connection. So to save time, what I'll do is I'll go back to catalog actually, and I'll open my app settings.json file over there, and I'll just copy these two sections from the app settings.json. I'll go back to inventory and I'll paste that right here. Really the main thing, the only thing that we have to change here is that this is not the catalog service anymore. This is the inventory service. Remember that this is what's going to define the name of the database that's going to be created in MongoDB. Save that. And now I'm going to go to startup. I'll actually clean up a bit these namespaces. So I'll do control dot here, remove necessary usings. And now I'll go to the start of configure services. And I'll add the services for MongoDB and the repository. So I'll do services dot add Mongo. And that may need another import, paycom MongoDB. And then I'll add Mongo repository of type inventory item. Let's add a using there. And here we have to specify the name of the collection here. So the name that we're going to give it is inventory items. Save that. And so with that, we have registered everything related to MongoDB. And we actually are ready to start trying out this microservice. So I'll go ahead and hit F5. Okay. And then what I like to do is actually import the specification of our API into Postman to make our lives a bit easier. What I'll do is I'll copy the URL of our service, localhost 5005. And then I'll go to our browser just for this time, paste that there, and then let's go to Swagger. So this defines, as you can see, this is the Swagger UI page for our REST API. Then I'll click in the swagger.json link here, and I'll copy that. And then I'll just close this browser. Now I'll go to Postman. And here what I'll do is I'll just click on import link. I'll paste that. Click continue, and I'll just say import. So now if we go to collections, we have now not just a catalog service section, but also a collection, but also a plain inventory service collection with our two items related operations. So what I'd like to do is to go ahead and try out our post to assign an item to a user. But of course, before that, we have to define the base URL for for this collection. So let's go to ... Let's go to edit, variables. And in this case, our base URL is, as you remember, let's go to inventory. Base URL is localhost 5005. Put that here. I'll put it for current value and for initial value. Update that. Okay, so it knows the base URL. Now, being in post, we code the body, and here's the three things that we need: user ID, catalog item, and quantity. Now, for the user ID, like I said in the introduction, we don't have actual users so far, so we just generate a random one. And one handy way that we can do that in Postman is by using the GUID function that's built into Postman. So what you can do is just this. So open two sets of curly braces, and then you're going to do just GUID. So that will on the fly generate a GUID for us. And for the catalog item ID, we want to know the ID of one of our items in the catalog. So to do that, let's actually query our catalog items. But before doing that, let's go back to catalog and just hit F5 to actually start the web server so that we can query the catalog. And then I'll go back to Postman. Into our play catalog service collection, I'll expand this. I'll go to get items and I'll just hit send. And here is the one item that we have in the catalog, the potion. So I'll copy this ID. And I'll go back to our post operation, paste it there. And let's say that we want to assign just one of these potion into the user's inventory. So now I'll go ahead and hit send. And we got 200 OK, meaning it was a success. And so to verify that this actually worked, let's actually try out our get all items in the inventory operation. So I'll click on this new operation. And in this case, the first thing that we're going to need is to specify which is the user ID, right? So which user was that item assigned to, which if you go back to post, it was an automatically generated user. We actually don't know yet, but we can figure that out via our console. So I'll click on the console down here. And you open the post operation and we expand the body, the request body. You see that the user ID is right here. So the console records everything that's going on behind the scenes. So it's pretty handy in these cases. So I'll just copy the user ID and I'll close this. Then I'll go back to our get items from the inventory service and I'll paste that right here. So with that, I'll go ahead and hit send. And here it is. So this user has one of the catalog item of this ID and with this acquired date. The date was assigned. And so let's say that we wanted to increase the quantity of that item for this user and we want to actually test this other code path. So let's go back to post body and let's say that we want to add perhaps 4 more potions to this user's inventory. So I'll just do that. We want to change now, we don't want to generate yet another GUID. So I'll replace user ID with the ID that we just copied for our user. So then I'll go ahead and hit send, 200 OK. And then if we get items for this user in inventory, I'll hit send. And now the quantity is 5. So now the user has 5 items in his inventory. Okay. So at this point, our inventory service can store and report the items that each user has in his inventory bag. However, notice that this DTO that we have returned by the get operation only provides the IDs of the items in the user inventory. So since we don't have any names or descriptions, it is a bit hard to tell which items are in the user inventory, which are the actual items. So what does 4E9C means really? So in the next lesson, we will learn about microservice communication styles and how our inventory service can use them to retrieve more details about each of these items from the catalog service. In this lesson, we will learn about the different microservice communication styles and how to implement the synchronous communication style via REST and the HTTP protocol. There are basically 2 ways you can communicate with microservices. The synchronous style, where the client sends a request and waits for a response from the service, and the asynchronous style, where the client sends a request to the service, but the response, if there's any response, will not be sent immediately. So far, we have been using the synchronous communication style when interacting with our services via Swagger UI and Postman, and in this lesson, we will explore how to use it for inter-service communication. We will learn about the asynchronous communication style in a future lesson. When using the synchronous communication style, the client sends a request and waits for a response from the service, which means that the client cannot proceed without a response. You may make this more evident with any of our services if you put a breakpoint in one of our service controller actions, like get async in the catalog items controller, start a debug session in VS Code, and then try sending a GET request to it via Postman. You will notice that Postman waits indefinitely for our service to respond. It can't continue until the service responds. Many times, this type of communication uses a blocking thread, meaning that the client is unable to receive any other inputs or perform any other task until the response arrives. But it could also use a non-blocking thread where the client just offers a callback method to the service, so the service can call the client back when the response is available. In this case, the client thread does not block, even when it still waits for a response. There are two approaches currently to use the synchronous communication style. REST with the HTTP protocol, which is a traditional approach and the one that we have been using so far. In REST, the business objects are modeled as resources, and HTTP verbs are used to manipulate them. Also, you usually use XML or JSON to represent the resources. Most clients support REST. The other approach is gRPC, which is a binary message-based protocol in which clients and servers exchange messages in the protocol buffers format. gRPC is becoming increasingly popular because it supports HTTP2 and is more efficient than REST. However, not all clients support HTTP2, which is why in a microservices architecture, gRPC is used mostly internally between the API gateway and the services, or between the services. In the next lesson, we will be implementing synchronous communication between catalog and inventory microservices using REST and HTTP. At this point, when the client requests the items in the inventory back for a user, the inventory service queries its database and retrieves an array that has basic info about each item, including the catalog item ID and the quantity. However, having a list of item IDs does not tell much to our client in terms of what actual items the user has on inventory. Ideally, we would like to get at least the name of each item and hopefully also its description. However, inventory doesn't know such details about the items since that information is owned by the catalog service. One way to address this is to have the inventory service send a GET request to the catalog service to retrieve the details of all the items. Inventory can then combine this additional info with the details it has in its own database to send back the desired more detailed payload to the client. Let's go ahead and implement this approach. Our inventory microservice needs to receive data from the catalog microservice. But before it can do that, it first needs to define the DTO that represents the retrieved catalog items. Now it turns to be that we already have such a DTO that represents catalog items. And if we go to our catalog project, our catalog microservice, and if we go to DTOs.cs, we're going to see that such a DTO is right here. So this is the DTO, item DTO, that represents catalog items when you query for them. So what I'll do is I'll just copy this DTO, copy this, and then I'll go to inventory. Here we are in inventory, and I'll open DTOs.cs, and I'm just going to paste that as initial DTO for the inventory. Now in the case of inventory, we're going to rename this into catalog item DTO, just to not confuse it with inventory item DTO. And for the case of inventory, again, we don't need that many properties when we're querying for catalog items, and you don't have to retrieve everything, or at least serialize everything into inventory. The only thing that we're going to need in this case is the ID of the item, the name, and the description. We don't need price and created date for our purposes, so I'll remove those. Save this. And now that we have this DTO, we can actually build a client that is going to be able to query for these items from catalog. So I'm going to right click in Play Inventory Service. I'll create a new folder. Let's call it clients. And in this one, I'm going to create a new file that I'm going to name catalog client.cs. Let's give it a namespace. Let's Play Inventory Service clients. Public class catalog client. So in order for our catalog client to be able to talk to any external HTTP endpoint, it needs to use the .NET HTTP client class. So we're going to define that as a class level variable here, private read-only HTTP client, and I'll import the system.net.http namespace. And now we're going to do dependency injection of this client into our class. So public catalog client, HTTP client, and we'll take that reference. Now that we have that client available, we're going to define the function that's going to actually retrieve the items from catalog. So this is going to be an async function. So let's define it as async task. And what we're going to return is a collection of catalog item DTO. Since the consumer is not expected to modify this collection in any way, we're just going to return a read-only collection of type catalog item DTO. And we'll name it get catalog items async. Let's import missing namespaces for task and for read-only collection and for catalog item DTO. To retrieve the items, we can do that really easily with one line. So we'll do items equals, we'll do wait, HTTP client, get from JSON, let's change this, get from JSON async. We need to import another space, system.net HTTP JSON, and we'll deserialize as I read only collection of type catalog item DTO. And then here is where you put the route that you want to access in the invoked REST API. In our case, in the cases of catalog, the route would be under items. And with that, we can go ahead and return the items. That's all you have to do to invoke another a REST API in another service. With that done, it is time to update our inventory item DTO to have this additional information that we're going to collect from catalog. So let's go back to DTOs. And in inventory item DTO, we're going to add a name and a description. But as we do that, as we can see, extension is complaining, and it's because we need to provide those additional members to the construction of inventory item DTO as we transform the inventory item entities. So what we'll do is we're going to receive additional parameters into this method, which are going to be the name and the description. And we'll feed those two into inventory item DTO constructor. There. With that done, we are ready to go to our controller to actually take advantage of this new information. So I'll go to items controller. And the first thing I'll do is I'll get a reference, or I'll define a class level variable for our catalog client. So I'll define private read-only catalog client. Okay, let's import the missing namespace. And let's receive that as dependency injection into items controller. I receive the catalog client, and we'll get the reference. And now that we have that, let's change a little bit how we do our getAsync method. So we'll get rid of these lines for now. And the first thing that we're going to do is to actually retrieve the catalog items. So how do we get the catalog items? Very easily. Now we can do catalog items equals await catalog client dot get catalog items async. That's all it is. Okay, so that gives us all the catalog items in the catalogs microservice. Now we want to get the list of all the inventory items that we have currently in the inventory microservice. So we'll do that via inventory item entities. Is going to be await item repository get all async, where the item.user ID equals the user ID that we got as a parameter. Okay, so now we have all the catalog items, and then we have all the entities, the inventory item entities for the current user. Now we need to combine these two pieces of information to produce the DTO that we want to return. So to do that, we'll do this. So inventory item DTOs equals inventory item entities. Select, so we're going to do a projection here for each inventory item. We will do this. Let me close that. First, we will look into the collection of catalog items and we will find the catalog item that corresponds to the current inventory item. So catalog item equals catalog items. That's single. There should be one and only one catalog item where the catalog item that ID should match exactly the inventory item that catalog item ID. And once we have that, we can do the conversion of the inventory item into a DTO. So we will do inventory item, return inventory item as DTO, and then we have to provide the catalog item that name and the catalog item that description. And finally, now that we have the inventory item DTOs, we will return those as opposed to this all items collection. So inventory item DTOs. So our getAsync method is ready to retrieve an improved set of items with name and description. And now it is time to do the proper registration in a startup to let our application know about this new catalog client that we're going to be using. So let's go to startup. And what I'll do is I'll open a little section just under our Mongo registration. So I'll do services.add HTTP client, and our client is going to be catalog client. Let's import missing namespace. And then I'll receive specify a parameter here. It's going to be the client. Okay, let's open that expression there. And here really the only thing that we have to specify for now is the base address of this other microservice, because otherwise how would it know? So we're going to say that the client base address equals a URI. Let's import a missing namespace. And then if you remember, the URI where our catalog microservice lives so far is a localhost 5001. So that's what you have to specify here, HTTPS localhost 5001. Okay, so this is a handy way to register our catalog client so that it can be used by dependency injection in other classes like in the controller, right? So you say add HTTP client, catalog client, and then you specify the base address. And then when that client is instantiated, it will automatically receive an instance of the HTTP client that you're going to be using to query for items. Okay, so with that done, let's go ahead and hit F5. Let's see this in action. Let's not forget to also do an F5 in our catalog microservice. So I'll go ahead and start also, here's catalog. I'll start it F5. And with the two services up and running, we can go ahead and go to Postman. And here in Postman, I am already in the tab for the operation that can retrieve all the inventory items for the specified user ID. So this is user ID that we used in the previous lesson. So let's see what information we can get now that we query the API. So we'll go ahead and hit send. And as you can see, we are able to retrieve the catalog item, but this time we not just have the ID of the item. We also have the name and the description of the catalog item. Okay, so this seems to be working pretty well. However, think about what will happen if the catalog service starts having issues, at least temporarily, or what happens if it's completely down. In the next lesson, we will learn about the problems that we might find when having a service communicate with another service. In this lesson, we will learn about partial failures in microservices and how to deal with them using timeouts and the exponential backoff technique. Even after placing our best efforts to ensure we have a healthy system, it is a matter of fact that in distributed systems, partial failures will happen. This could be due to multiple reasons, including network outages, hardware failures, dependency failures, and even routine things like having a deployment in progress. Regardless of the cause of the partial failure, when calling a dependent service, it could certainly cause our microservice to fail, which will end up in a bad experience for our clients. So, whenever a service makes a synchronous request to another service, there is an ever-present risk of partial failures, and so you must design your service to be resilient to them. One of the first things to consider when making requests to a dependent service is setting appropriate timeouts. A service client should be designed not to block indefinitely and use timeouts. Think about the experience of our client when the catalog service takes a long time to come back to our inventory service, if it ever comes back. Now the inventory service is also taking forever to respond to the client, leaving our users with a bad experience. And not only that, at least one of the threads of inventory is now busy not being able to serve any other requests, which reduces the amount of available resources in the service. Instead of this, you can set a timeout of, say, no more than 1 second, so that if catalog service takes more than that to respond, the request immediately fails, and the inventory service can in turn return the appropriate request to the client, even if it's a failure. This enables a more responsive experience and also ensures that resources are never tied up indefinitely. Like we mentioned, it is not uncommon for transient failures to occur in a distributed environment. Therefore, you usually want to give the dependent service one more chance to come back with a successful reply. However, you don't want to keep retrying at a constant rate, since that could overwhelm the dependency. A good strategy that you can use for retries is the one called retries with exponential backoff. This strategy performs call retries a certain amount of times with a longer wait between each retry. And here's how it works. As usual, the client will make a request to our service, and this one in turn will make a request to its dependent service. If this second request fails, instead of failing right away, our service will wait some time, and then it will try again. If the request fails again, we will now wait a longer amount of time before trying the request. If it keeps failing, we will wait a yet longer amount of time before one more try. And eventually, if we have tried enough times with no successful response, we will let the call fail. As you see, this strategy lets a failing dependency have an increasing amount of time to recover. It also avoids overwhelming the dependency. Let's see how to implement timeouts and retries with exponential backoff in our inventory microservice. Let's see our inventory and catalog microservices in action once again. So here I am in catalog, and I'll just hit F5 to start a web server. And then I'll go to inventory, and I'll do the same thing, hit F5. And now I'll go to Postman, and I'll try to get all the inventory items for this user ID. So I'll just go ahead and hit send. And here's what we expected to get, right? So the list of inventory items with name and description. Now, to simulate the effects of partial failures, let's first add a few temporal modifications to our get all items operation in catalog microservice. So I'll go to our catalog Visual Studio Code instance, and I'll stop it for now, close terminal, and I'll go to items controller. And what I'll do is I'll modify our get async method, the one that retrieves all the items, so that it introduces a few temporal failures for our inventory client. So before doing that, I'm going to add a little variable to track how many requests we have received from the client at this point. So I'll just add private static int. I'm making it static so that it doesn't reset after every request. Let's just call it request counter. Start with 0. And now in get async, I'm going to open space here. Let's go down. And I'll do the following. The first thing that I'll do is I'll just increase the counter. And then let's add a log line just after this. Console.writeLine. We'll just say string interpolation, request, request counter starting. So that's what it tells us that it's starting a new request. Then what we're going to do is for the first two requests, we will actually increase, we'll add a delay to simulate the timeout scenarios. So if request counter less than or equals to 2, we're going to say, I'm going to copy this line here, console write line. We will say delaying, and I'm going to say await task delay. This is how you can introduce a delay in the current request in an asynchronous way. Time span that from seconds will say 10 seconds. So the first two requests will be delayed 10 seconds. Then I'll copy this block here, down here, and we'll say that if the request counter is less than or equals to 4, what we're going to do is just return an internal server error, right? So to simulate that kind of error. So request counter, we will say 500 internal server error. And we will return status code 500. Now at this point, we are introducing this capability of returning either one result here or another type of result here. And in order to do that, remember that we have to switch from just returning the IEnumerable into returning an actual iAction result. So I'll say action result of IEnumerable of item DTO, and I'll close this. So that gives us the ability to return more than one type of result. And also we'll have to modify our final return clause here so that it returns something that can be mapped to action result, like the OK result. And lastly, what we're going to add here, just over here, let me copy this console write line. This is going to be the happy path where we finally return something. And we're going to say request counter. We will just say 200. OK. Okay, so for a quick review, we have a static request counter. So every time a request comes in, it increases the counter. The first two requests are going to have a 10 seconds delay. The next two requests are going to end up in a 500 error. And then if we get past that, we'll get a 200 OK. And so at this point, I'll go back to our inventory. This is our inventory Visual Studio Code instance. I'll just stop it, close. And what I'll do is I'll first go ahead and collapse our navigation pane for now. I'll open my terminal over here. I'll open a new partial terminal. What I'd like to do is actually have two terminals in this window so we can see the interactions between microservices. So I'll use the split terminal icon here to open a second terminal. And in this one, I'll actually switch back to play the catalog directory. Okay. Play that catalog service. And here I'll do .NET run so that we can see the outputs that are coming out of catalog. And then on the left side, I'll start up our inventory microservice. Same way, I'll do .NET run. Okay, so with that done, let me go back to Postman and I'll try the query once again. So I'll hit send. And back in VS Code, you can see that now this first request is getting delayed. And now our inventory client is experiencing this significant timeout. If we try it again, from the point of view of Postman, so look at this. It just keeps waiting, waiting, and waiting. We're giving a really bad experience to our clients, right? Okay, so what can we do about this? So the first thing, as we mentioned, is to introduce a proper timeout to avoid this kind of situation. So let's go back to Visual Studio Code. And what I'll do now is I'll stop both web servers. So I'll go to my inventory terminal. I'll do Control-C, stop server, catalog, Control-C, stop server. And what I'd like to do now is to add our reference to the poly NuGet package. So this is the package that you can use in your .NET applications to properly handle transient error failures in a very easy way. So being in play inventory service, I'll do .NET add package Microsoft.extensions.http.poly, enter. Okay, And then perhaps I'll put this back into place, and then I'll just do Ctrl-J to hide our terminals for a moment. Then I'll go to our Explorer and I'll go to startup.cs and I'll collapse this once again. We don't need it. And let's go into configure services. And yeah, so let's find the section where we are adding the HTTP client right here. And here what we're going to do is we're going to append yet another call to another method here that's called add policy handler. And here's where we can define a policy. So Poly has this concept of policies that different policies that can be used to handle different transient errors when you're invoking an external API. So we're going to use policy, and then let's import any missing namespace using poly. So we will say policy dot timeout async. And then we have to specify a type here, and that type is going to be HTTP response message. And let's add the system.net namespace, because this is the type of response I will get when you invoke the external client. So, and in this parameter, we want to specify how many seconds we want to wait maximum after calling an external API and before just failing. So I'll say 1 second in our case, and I'll close this. So just by doing this, you're saying that anytime we invoke anything under localhost 5001, we're going to wait at much 1 second before giving up. So let's see now how this works. I'll bring in back my terminals via Ctrl-J, and then I'll do .NET run in both cases. Okay. Perhaps I'll move this a little bit to the right. And then let's go to Postman and try the request once again. And as you can see, it now took just a little bit more than 1 second to complete the request. So instead of waiting for all those 10 seconds, wasting resources. Let's try again. Yep, and once again, it just took just a bit more than 1 second. If we go back to Postman, we can also see we tried the 2 requests on the right side, but then they actually took more time to respond. But regardless, we had already failed on the left side, on the inventory side. So that would at least help us fail fast to avoid the long delay and avoid consuming inventory resources unnecessarily. However, we note that transient errors are not uncommon in distributed systems. So we would like to not just fail right away, but instead try a few times, hoping for the catalog service recovery. In the next lesson, we will implement the retries with exponential backoff technique to improve our chances of succeeding in the presence of transient errors. In the last lesson, we introduced a 1-second timeout policy to our inventory microservice. Let's now use the retries with exponential backoff technique to let inventory retry the calls to catalog a few times before giving up. So here I am once again in the play.inventory microservice, and here's a line where in last lesson we added our timeout policy. What we want to do here is add yet another policy to specify what to do in the presence of transient errors and how to retry. So now I'm going to be adding that policy handler right here, just between the add HTTP client call and the add policy handler call. And just pay attention of the location of this, because we want to make sure that we can combine the timeouts with the transient error handling, so that anytime that we retry, we actually wait just 1 second, like specified in this policy. We wait 1 second between tries. If you don't do things in the order that are going to be shown here, that combination is not going to work properly. So at this location, I'm going to say add transient HTTP error policy. And let's actually go into the definition of this method for 1 second. So go to definition. So just so that you can see what this method is handling. So this method is taking care of network failures. It's also taking care of 500 errors, server errors, and 408 status codes, so request timeout. So this method we're going to use is very handy, because it can handle all these situations by itself automatically. I'll close this. And again, notice the location where I added this. So now what I'll do is I'll say builder. And then we'll say builder dot wait and retry async. And here we're going to open parentheses, and we need to specify a series of parameters for this policy. And the first parameter is going to be the retry count. So this is how many times we want to retry in the presence of transient error failures. So for our case, let's say we're going to go for 5 retries. The next parameter is the sleep duration provider. So this is just a function that determines how much time to wait between each retry. So for this, we're going to say retry attempt, and then we'll use a time span class to specify a duration in seconds. But here is where the exponential backoff part comes into place. We're not going to just specify one specific amount of seconds. We're going to say mat.pow so that we can say, let's go for 2, and then we'll raise that into retry attempt. So this means that every time we're going to wait, we're going to be waiting an increasing amount of time that depends on the retry attempt. So for like the first time is going to take 2, raise it into 1, the first retry attempt. So 2 at 1 is going to be 2, so 2 seconds. So next time is going to be 2, raise at 2, so it's going to be 4 seconds. Then next time 8 seconds. It will keep going that way in an exponential way, so that every time we just wait a little bit more. So that's exponential backoff piece of this technique. And then next, we're going to specify yet another parameter that you don't really need it, but we're going to use it just for the purposes of demonstrating what happens between the different calls. So you can totally skip this if you don't want to see what's going on behind the scenes. So I'm going to say on retry, and then we need to specify 3 parameters. It's going to be outcome, time span, and retry attempt. So I'll open this, and then here we can specify what we want to do each time that a retry happens. What we want to do is just present a log message in the console, and we can do we can use iLogger for this. Now, to do that, at this point, we need to actually get an instance of the iLogger class, but we don't have an easy way to do that right now. So what we're going to do is to, as an instance of the service provider, we're going to create a service provider, and from that one, we're going to get that service. This is not ideal, and that's actually going to present a warning message in the console, but we're doing this just for demonstration purposes, so totally avoid this technique in production code. So let's see, we'll say service provider equals services dot build service provider, and then we will say service provider dot get service. We want an iLogger of catalog client. Okay, let's see if we're missing a namespace. The extensions logging. Okay, so if you're able to get that service instance, so we'll use this question mark there, we'll say dot log warning, and here's where we're going to specify that message. And the message is going to be, and we'll do string interpolation here, we'll say lane for so many seconds, and those seconds are going to come from time span, the total seconds, and then making retry, and that's going to be retry attempt. Okay, close that, save. And one more thing that we have to do here is make sure that we combine both of these policies so that they can work together. And to do that, what we have to do is go back to this builder declaration here. So and then we have to say builder.or, and then we specify the exception that will be coming out of the timeout async call over here. So in that case, that exception is going to be timeout rejected exception. And then let's see if we're missing a namespace using poly timeout. Okay, so that's how you can say that if the actual, and let's add missing parentheses, if we fail because of a timeout produced by the timeout policy, then it will fire a timeout exception. Let's go ahead and also retry. Okay, so that's the right way to combine both policies. Okay, so now let's just save this, and I'll open my terminals. And left side is inventory. I'll do .NET run. Right side is catalog, .NET run. Let's expand this a bit. And notice the warning that I was mentioning before. And this happens, like I said, because of the way that we're doing the service provider construction here. There's already a service provider built into the ASP.NET Core runtime. We're creating a second one. That's not ideal. But like I said, it's just for demonstration purposes. Feel free to remove this section in your production code. So now that we have both services up and running, let's go back to Postman. And let's go ahead and do a send to see what happens. So it starts, and going back here, you can see that first time we tried, and then we waited 2 seconds, then we waited 4 seconds, then we waited 8 seconds. We're trying to wait 8 seconds. On the right side, you can see that the multiple requests that are coming in, now they're firing internal server errors. And now we are in what's probably the last wait for 16 seconds. And so the client in Postman, as you can see, it just keeps waiting. It doesn't fail right away, but we are trying to get a chance to actually succeed. And yeah, eventually that happened. The client succeeded, and we no longer see an error. If we see back into Postman, we can see that, yeah, indeed, eventually we got a 200 OK for the last request, and it's looking great. Now, the one issue with this is that if you have multiple instances of your, in this case, of an inventory service calling a catalog, and they are all waiting exactly 4 seconds, exactly 8 seconds, 16 seconds between retries, that can actually cause a kind of bursts of calls into catalog service at the very same time, right? Because they're waiting for exactly the same time between retries. So to avoid overwhelming our catalog service, what we can do is introduce a little bit of randomness so that it is not exactly 4 seconds or exactly 8 seconds and stuff like that. So how can we do that? I'll do Control-C in both of my terminals to stop those processes and do Control-J to close the terminals. And what we're going to do is add what we call a jitter. So this is going to be the way to add that randomness here. So I'll go up, and just over here, I'll introduce a random jitter. It's going to be new random. And then let's go back to the section where we're defining the retry attempt over here. And what we're going to do is just go to next line, and we will say plus time span dot from milliseconds, and we will say jitter dot next. And so we want to add is some number of milliseconds to those seconds. So we'll say any number from 0 to 1000 should be fine. So this time we should see that it's not just a specific amount of seconds, but those seconds plus some milliseconds that are going to be generated at random. So I'll save that, open terminals again, Ctrl-J, .NET run, and .NET run. Okay, and let's go back to Postman and try this again. So I'll hit send. Let's go back here. And as you can see now, we are not waiting just 2 seconds, but 2.523 seconds. And the next time we're waiting for that 338 seconds, and so on and so on. So with that, the different instances will be invoking back to a client at slightly different times, which lets a catalog not get overwhelmed. And so this is much better and would certainly help us handle temporal glitches when reaching out to the catalog service. However, imagine that a widespread network outage is preventing us from reaching catalog, or perhaps is preventing catalog from reaching its dependencies. So such outage would likely last, let's say, a half an hour. And if we have all of our inventory service threads retrying that much time, we may end up exhausting its resources. In the next lesson, we will learn more about resource exhaustion and how to deal with it via the circuit breaker technique. In this lesson, we will learn about resource exhaustion in microservices and how to deal with it using the circuit breaker pattern. Having a retry policy in place is good, but you also must be mindful about the limited resources available to your service. Imagine once again a situation where there is an ongoing issue with your service dependency. This might not be just a transient issue, but instead some prolonged downtime caused perhaps by a broad network outage. Now the client calls our service, and this one in turn invokes the already failing dependency, which will hopelessly start waiting for a reply. While this is happening, more clients keep sending requests to our service, and this results in more requests being sent to the failing service. One thing you have to realize is that each of these requests are making use of your service threads, of which there is only a limited amount. Once enough threads are in use, there are no more resources available, and you can reach what we call resource exhaustion. When this happens, your entire service becomes unavailable for any future requests, potentially causing a lot of trouble in the system. One approach we can use to properly handle this issue is implementing the circuit breaker pattern. A circuit breaker prevents a service from performing an operation that's likely to fail. Here's how it works. Once again, we are in a situation where our dependent service is already in a bad state, unable to provide successful replies. Our client then makes a request to our service. However, this time, instead of invoking the failing dependency directly, there is an intermediary that we will call the circuit breaker. The circuit breaker will now start monitoring the results of each of the requests that go through it to the external dependency. And when it detects that the rate of failure goes beyond the configured threshold, it will immediately stop letting any more requests go out and will fail them right away. This is what we call opening the circuit. After this, requests will just keep failing immediately during the configured wait time, which would hopefully give the dependent service enough time to go back to a healthy state. Eventually, the circuit breaker will let some requests go out to verify if they succeed. And if that is the case, it will close the circuit again, letting all further requests reach the dependent service. That's how the circuit breaker prevents our service from reaching resource exhaustion, while at the same time avoids overwhelming dependent services until they get a chance to recover. Let's go ahead and implement the circuit breaker pattern in our inventory microservice. To implement the circuit breaker pattern, all that we have to do is add a new transient HTTP record policy, just like we did for the wait and retry policy. So here we are again in the inventory microservice in the startup class, configure services method, and I'm going to scroll down a little bit here. And remember, we have already added a policy for wait and retries, and we have a policy for timeouts. So what I'll do now is I'll open yet another section here to add our next HTTP record policy. So I'll do add transient HTTP record policy. Remember that we want to do this just before the timeout and not after, so that this policy can also wrap the benefits of the timeout policy. So I'll open parentheses here, and what I'll do is I'll just copy this little section here so that we are properly combining this policy with the exceptions that could come out of the timeout policy. But then what I'll do is I'll invoke the circuit breaker async method here, and I'll open parentheses. And here we have to specify the parameters for circuit breaker. So the first parameter that we have to specify here is how many tries we're going to allow, or how many requests we're going to allow through the circuit breaker before the circuit has to open, right? So in our case, let's say that's going to be 3. So 3 failed requests are going to go through the circuit breaker before the circuit breaker actually notices that, yeah, there's a problem and we have to open the circuit. Next comes the duration of the, or time span of the break. So this is how much time we will keep the circuit open. So let's say this is going to be time span from seconds, let's say 15. And that's really most of what you have to do. You don't have to do more than that to enable the circuit breaker. But just like we did with our retries, let's add a couple of functions here to get an insight of what's going on behind the scenes. So what I'll do is I'll say on break. So this is a function that will be used when the circuit opens. So I'll say outcome and time span. Okay, so in this case, we want to add a log message and stating that the circuit breaker is opening. So this is going to be really very similar to what we did for our wait and retry. So I'm actually going to copy these 3 lines from here, I'll copy them over here for our onBreak function. And I'll just change the message the following way. So I'll delete this and I'll say opening the circuit for, and this is going to be time span that total seconds. Okay, so that's what's going to happen when the circuit breaker opens. And then next, we're going to add another one for the onReset function. That's not going to receive any parameters. And in this one, we're going to do something very similar. So I'll copy again those lines, paste them there. And in this case, we're just going to say closing the circuit. Okay, so that's really all you have to do to enable the circuit breaker. So again, we are waiting. We will allow 3 requests to go into the circuit breaker, and if those 3 are failing, the circuit is going to open. Then it's going to wait 15 seconds before allowing any new request to actually try to reach the other end. During those 15 seconds, things are going to just fail right away. And then we have functions to log what's happening when the circuit opens and when the circuit closes. So now I'll go ahead and I'll open my terminal. So I'll save this file. I'll open the 2 terminals. Just like in previous lessons, I have 2 terminals: inventory service on left side, catalog service on right side. I'll do .NET run in both sides. Okay, notice we keep getting these warnings about the build service provider issue that we talked before, but like I said, this is just for demonstration purposes. So now I'll get back into Postman, and we'll try out that inventory API to get all the items in the user's inventory. See what happens. So I'll just go ahead and hit send. And notice on the left side that we failed, so we waited for 2.002 seconds, then we tried, failed, waited for 4.644 seconds, and then at that point the circuit actually opens for 15 seconds. So we're waiting 8.71 seconds for the next try, but the moment that we try this again, things fail right away, as you can see on the left side. And if we see what's happening in Postman, yeah, we're getting that error. The circuit is not open, is not allowing any further calls. And if we try once again, it may take 1 or 2 seconds, but it will fail because the circuit is open. And if we just keep trying and keep trying, we're getting an immediate result. So this is the effect of having the circuit open. So any new requests that are coming here from any client into our service are going to fail right away. However, eventually the circuit lets us go through one more request. And if it notices that it's successful, it opens the circuit like it happened right here. If we go back to Postman, we can see that it allowed one more request just to see if things are healthy once again. And it got a 200 result. And then it said, yeah, closing the circuit, and it allowed things to keep working once again. So that's how the circuit breaker works, and that's how it can help us prevent overwhelming other services or having to waste resources and cause resource exhaustion in our microservice. At this point, we are doing a fairly good job at handling partial failures between our inventory and catalog services. However, could there be a better way to have inventory get all the information it needs from catalog without having to rely on catalog to be available most of the time? In the next module, we will learn about the asynchronous communication style and how it can help us enable a much more resilient communication between our services. In this module, you will learn about the asynchronous inter-service communication style, the challenges it can help solve, how to implement it via RabbitMQ and mass transit, and how to enable eventual data consistency between our 2 microservices. By the end of this module, you will have a solid understanding of the following: the basics of and when to use asynchronous communication between microservices, how to enable microservices autonomy and the impact to the SLA, how to use a message broker for asynchronous data propagation, how to stand up a RabbitMQ message broker via Docker Compose, how to publish messages to RabbitMQ via the mass transit framework, how to consume messages from RabbitMQ using mass transit, and how to implement eventual consistency of data propagated across microservices. In terms of our overall system design, in this model you will stand up a RabbitMQ server to act as a message broker that will store asynchronous messages in queues. Then you will update the catalog microservice to start publishing messages anytime the catalog of items is updated. After that, you will modify the inventory microservice to asynchronously consume these published messages and store the corresponding item information into its local database. And finally, you will update inventory to stop making synchronous calls to catalog and instead take advantage of the new catalog information stored in its local database. Let's get started. In this lesson, we will learn about the asynchronous communication style and how it can help us enable much more resilient communication between our services. Imagine a scenario where after receiving a request from a client, our microservice needs to reach out to two other microservices. Also, each of these services need to get in touch with other services, which in turn might need to further reach to more services. There may also be services that depend on the services that our service depends on. We originally fine-tuned our service so that it never takes more than 300 milliseconds to respond to our client requests. However, when we started making synchronous calls to one of our dependent microservices, we had to add to our time the 200 milliseconds that service can take to respond. That was still okay in the beginning, but unfortunately, when that dependency eventually started calling another dependency, and that one yet to another one, our overall average latency bumped to 1450 milliseconds, which is bad. On top of that, if one of our deeper indirect dependencies starts failing, even if temporarily, it can cause all of the services that depend on it to also start failing. And the effect keeps cascading until potentially most of our system becomes unavailable. One important concept that you should keep in mind as you embrace microservices is the Service Level Agreement, or SLA. The SLA is basically a commitment between you as a service provider and the client. For instance, as part of our SLA, we could have defined that our service can be expected to be up and running 99.9% of the time. So, when our clients choose to use our service, they should expect it to be down approximately 44 minutes during the month, which the owners of the client will have to decide if it's acceptable. However, when using synchronous communication, calculating such numbers for our service SLA gets more complicated. Our deepest dependency is also advertising a 99.9% uptime in their SLA. And let's say that all of the services initially advertise that same value. However, in our scenario, when dependency 4 fails, it impacts the SLA of dependency 3, which now sets its SLA down to 99.8%. This in turn impacts the SLA of dependency 1, and ultimately impacts our own SLA. Now, with an SLA of 99.6% uptime, our clients would be subject to about 175 minutes of downtime across the month, which is way below of what we wanted to provide initially. So the synchronous communication style suffers from an increase of latency due to the chain of calls. It can significantly amplify the impact of partial failures and can potentially reduce the SLA of our service. Now, let's look at the asynchronous communication style. Here, the client does not have to wait for a response in a timely manner. And in fact, depending on how the communication has been set up, there might not be any response at all. To enable such communication, there is usually an intermediary called the message broker, which is pretty dumb in nature, meaning that it has no business logic on it, and it is also highly available. With the message broker in place, the service client sends messages to the broker, and the broker forwards the messages to receivers as soon as possible. The messages can be received by two types of receivers. A single receiver, in which case we think of the message as a command via which the client requests an action on the receiving service. For instance, when a purchase operation starts, our trading service will send a command to our inventory service asking it to grant items to the user's inventory and another command to an identity service asking it to debit yield from the user. We could also have multiple receivers, where there are multiple services that subscribe to the events published by the client service. This would be the case if, for instance, our catalog service would like to publish any updates to its catalog of items so that other services can be informed about the changes. One of the key benefits of using asynchronous communication is that it enforces a microservice's autonomy. Let's see how it's enabled. In a single receiver scenario, we would have again our client talking to our service, but our service will not talk to its dependent service. It will instead send an asynchronous message to a broker, and it will immediately acknowledge to the client the successful reception of the request. The dependent service will consume this message from the message broker as soon as possible and will eventually provide a reply via the same broker. At that point, the client can request the status of its initial request to our service, or our service can notify the client of the response. All of the services in our system would follow the same message-based approach, including cases where a reply is not required from the called service. The great thing about this kind of layout is that when one of the dependent services fail, it would not cause any impact on the other services, since all of them have been decoupled from each other and only talk to the message broker. So the same SLA that one of the services presents can be honored across the entire system, assuming that the message broker offers high availability. So, with asynchronous communication, partial failures are no longer propagated. Each service has its own independent SLA, and best of all, the autonomy of all microservices is enforced given the lack of coupling between them. One of the nice things that asynchronous communication provides is the ability to asynchronously propagate data across services. In the synchronous communication scenario, when the client requests the user's inventory, and since the inventory service only has the data that's relevant to it, inventory has to first talk to the catalog service in order to retrieve additional details about each item. How can asynchronous communication help here? Well, thanks to the presence of the message broker, what we can do now is have the catalog service publish an event each time a catalog item is created, or updated, or deleted. Such event doesn't have to have all the details of each item, but only the ones of interest to client services. We can then have our inventory service listen to these events and create its own collection of catalog items in its own database. As long as we have a highly available message broker, the list of catalog items in the inventory database should be eventually consistent with regards to what's in the catalog service. Now, when the client requests the user's inventory has no need to go out into any dependent service to request item details. It has everything it needs in its own database, and it can immediately provide a reply to the client with no additional latency. So, thanks to asynchronous communication, we can enable eventual consistency across our system, the autonomy of our services is preserved, and the previous inter-service latency is reduced or completely removed. In the next lesson, we will start implementing asynchronous communication between our two microservices. We will introduce RabbitMQ as our message broker of choice, given that it supports the AMQP protocol, it is lightweight, easy to run locally, and is very popular in the open source community. RabbitMQ introduces the concept of exchanges, which you can compare to a mailbox. When a service like Catalog needs to publish a message, it will send it to an exchange in RabbitMQ. And with the appropriate bindings in place, the exchange will distribute the message to any of the configured queues. From there, RabbitMQ will take care of delivering the message to any subscribed services like inventory. We could use RabbitMQ directly in our code, but we would first need to create the exchanges and queues and configure the bindings to ensure messages are properly routed. Also, our code will be tied to RabbitMQ, and if we ever wanted to move to another message broker, we would need to rewrite a good part of our services code. For this and a few other reasons, we will instead use mass transit on top of RabbitMQ. Mass Transit is a popular open-source distributed application framework for .NET. Mass Transit can take care of doing most of the RabbitMQ configuration for us and is able to integrate with multiple other message brokers while allowing our services to stick with a higher layer of broker-agnostic APIs. As part of this, Mass Transit introduces the concept of a publisher and a consumer, which is what our service code will focus on. Let's start coding. Just like we need to define DTOs to establish contracts between our REST API and our API consumers, we also need to define the contracts that define the messages to exchange between services that use asynchronous communication. However, this time we will define the contracts in a separate project, mainly because we will later package and share the contracts with other services so that they can easily use them. So let's start by defining the contracts that our catalog service will use to send events asynchronously anytime an item is created, updated, or deleted. So here we're back in the play.catalog directory. And what I'm going to do is I'm just going to open up my terminal, Ctrl-J, and I'm going to switch into the src directory. And right here, what I'm going to do is just create a new class library. So let's do .NET new class lib, and we'll give it the name of play.catalog.contracts. Hit enter. Okay, and our brand new project has been created over here, as you can see. Now, the first thing that I'll do right away is to open up my project file, and just like we did with the other projects, we're going to be removing the implicit usings and the nullable settings here, because like I said, we are going to cover those at the very end of this program, right? We're not covering that here. So I'll close that. And then, before we forget, let's also go ahead and get a reference from our catalog service project into our contracts project, so that the service project will be able to start using those contracts right away. So I'll just switch into play.catalog.service here. And here what I'll do is add a reference via .NET add reference. And then we'll go into play.catalog.contracts, play.catalog.contracts.csprog. Hit enter. Okay, and what that does is that in the csprog file for the service, you will see now we have this new reference over here, this project reference, which means that the service project can now use any types that are defined in the contracts project. Right? So now let me close this. And then let's go into this contracts project. So the first thing to do here is to get rid of this class 1 that we are not going to be using. So just delete that. And then I'll go ahead and right click in the play.catalog.contracts directory. I'll say new file. And this file is going to be named contracts.cs. Okay, so let's give it a namespace. So it's going to be namespace play.catalog.contracts. All right. And here we're going to define one record for each of these interesting events. Right? Now, one thing to remember here is that we don't need to define every single property of the catalog item object in these events. Only we need to define here the properties that are of interest of our consumers, right? So for instance, if we define public record catalog item created, the properties that we're going to define here is what really matters for whoever consumes this event here. So for instance, likely the item ID will be of interest. So item ID, then we'll also get the name, and let's also add the description. Okay, those are the only items that we're going to define for this event here. Now, just like we did this, let me go ahead and define one more entry for catalog item updated. Okay, and for this one, we're going to define exactly the same properties, item ID, name and description. And lastly, we're going to define public record catalog item deleted. Now in this case, really the only thing that we need to communicate would be the item ID. So I'll say GUID item ID. Now at this point, I'll just go ahead and do Ctrl-Shift-B to make sure that things are compiling. I think we're missing using a statement here. So yes, so the IDE VS Code just detected that we're missing an import for GUID. So I'll do control dot. And since I'm not seeing the element here to import the missing statement, what I'm going to do is just Control Shift P, and I'll do OmniSharp, restart OmniSharp, right there. So that will restart the OmniSharp server, and hopefully will help us identify the missing usings. So it just restarted. All right, so let's go ahead and try this out once again. I'll do control dot, and as you can see, yeah, now we got it, using system. That's what we're missing here. All right, so let's build this again, Control Shift B. Yep, everything is building successfully now. All right, so with that, we have our items defined, our items in our contracts defined for the catalog item. And so in the next lesson, we'll update the catalog service to start using these contracts and a few new NuGet packages to start publishing messages to a service broker. It's time to update our catalog microservice so that it starts publishing messages anytime an item is created, updated, or deleted. So I'll start by opening a terminal so that we can bring in a couple of NuGet packages that we're going to need. So here I am in the play.catalog directory. I'll switch to src and to play.catalog.service, not the contract, but the service one. And here I'll add .NET add package masstransit.ASP.NET Core. Okay, so this one brings in a bunch of functions that we're going to use in order to interact with the mass transit libraries. And the next package is going to be masstransit.RabbitMQ. So this one introduces a couple of additional APIs so that we can explicitly use the RabbitMQ service bus. Okay, so with those added, let me close this terminal. And I'll go to Play Catalog Service and into our items controller. And perhaps I'll close the navigation pane for now. And here we're going to do a few things. First, let's get rid of this temporal code that we added in previous lessons to simulate temporal failures. So we don't need really any of this anymore. Remove that, and I'll also remove this request counter that we had added. Now, the first thing that we're going to need here in order to be able to publish messages is what we call a publish endpoint. So this is the class that allows us to really communicate that we want to send messages to some location. So I'm going to declare a variable of type iPublish endpoint. Let's call it just publish endpoint. And for this, we're going to need to import the mass transit namespace. And then we're going to receive this variable as via dependency injection into the constructor. And then we will grab that instance into our publish endpoint variable. Now we can go to each of our controller actions, operations, where we want to publish a message and start sending those messages. So I'm scrolling down into our post async method. And what we're going to do is that just after creating the item in our database, we're going to publish a message announcing that the item has been created. So I'll do await publish endpoint dot publish, and here's where we're going to use our new set of contracts. And we will start with our catalog item created contract. And let's see, control dot. We need to import the play catalog contract namespace. And here we have to provide, of course, the item.id, item.name, and item.description. And that's really all you have to do to publish a message. And I'll copy this line because now it's time to go to our put async method and do something very similar. So just after updating the item into the database over here, let's add and paste that line. But in this case, the method is going to be catalog item updated. And we will use the existing item variable that we have here. We'll use the ID, the name, and the description. I'll copy this once again. And let's go to our delete async method. And again, just after removing the item, we will go ahead and publish a message saying that we have a catalog item deleted, which is going to be just the ID that we received from the parameter. So yeah, so that's all you have to do. And so now any consumer of these messages that is listening to the queue, to the right queue, will be notified that an item has been created, updated, or deleted. Now what we have to do is to do the proper registration in startup to configure and to register the classes that we need for mass transit and for RabbitMQ. So I'll open my Explorer here, and I'll go first to app-settings.json. Here, just like we did with MongoDB, we need to add a little section for our RabbitMQ settings. So I'll open a section here. Let's name it RabbitMQ settings. Open a section here. And here, the only thing that we're going to declare at this point is the host. So where is this RabbitMQ server living? And in our case, since it's all local machine, it's just going to be localhost. You could specify more details like username, password, and a bunch of other settings. But for now, for local purposes, we will just accept the defaults and we will go with localhost. Save that. Now, just like we did with the other settings classes, we need to introduce a class that represents the RabbitMQ settings so that we can use that in startup. So I'll create a new settings directory here now. And of course, we will move this later into our shared common library. But for now, let's just do it here, and we will do that refactoring later on. So I'll add a new file into the settings directory. Let's call it RabbitMQ settings.cs. Let's add a namespace. Play that catalog, that service, that settings. And then let's declare our class, public class, RabbitMQ settings. And as we know, the only thing that we need here is the host. So I'll declare our string host. And as with any other settings class, we will use this as an init as opposed to set, because nobody should be setting these properties after they have been deserialized from the configuration file. I'll save that. And now it's time to go to startup to register what the services that we're going to need. So I'll go to startup, and again, I'll collapse this navigation pane. So here in startup, I'll locate our configure services method right here. And then we will add the mass transit classes just before the controllers. Let's do it here. So we're going to say services that add mass transit. And we will receive a variable here that we're going to be using to configure things. I'll open a section here. Close this. Let's see if we're missing something. Yeah, so we need to import the mass transit namespace. And then we will use this X variable here, that we call the configurator, to specify the type of transport that we want to use. In our case, that transport is going to be RabbitMQ. So we have to say X dot using RabbitMQ. And then we need to specify a function to configure the RabbitMQ. So in this function, we're going to declare two parameters, which are going to be the context and the configurator. And then let's give this function a body. Let's close that, save. And the first thing we're going to do here is to get an instance of those RabbitMQ settings so that we can figure out what's the host that we're going to use. So we will just say RabbitMQ settings is going to be configuration, get section, and then the section that it should have the name of RabbitMQ settings. RabbitMQ settings class. And let's see if we're missing something. Yeah, we need to import the play catalog service settings namespace. And when we have that, we can say, okay, so now get it as a RabbitMQ settings type. Okay, so we have the settings, and now what we can do is use the configurator to set the host where our RabbitMQ instance lives. And that's going to be in RabbitMQ settings.host. And now we'll add one more line. This is not necessary, but I think it's very handy. And this line is going to help us define or modify a little bit how the queues are created in the RabbitMQ. So I'll do configurator.configure endpoints. And here we're going to receive the context and a formatter. And what we're going to use is the kebab case endpoint name formatter. See if we're missing something. Yeah, we need mass transit that definition. And in this formatter, we're going to define first the prefix that we're going to be using for our queues, and that's going to be service settings dot service name. And then we will not need to include the full namespace of our classes in those queues. So we'll just say false here. And lastly, we'll add one more line just after this one to start the mass transit the hosted service. So we'll say services.add mass transit hosted service. This is the service that actually starts the RabbitMQ bus so that messages can be published to the different exchanges and queues in RabbitMQ. So I'll save that. And for one last change, I'll go to our Explorer, and I'll go to app settings.development.json. This is something that I like to do more for demonstration purposes than for anything else. But this is changing the default logging level from information to debug. So I found that this is going to be very handy for us to understand what's going on behind the scenes when messages start flowing between services. So we'll do that over here. And at this point, the catalog microservice is ready to publish messages to RabbitMQ, but we don't have a RabbitMQ instance available just yet. In the next lesson, we will expand our Docker Compose file to also stand up a RabbitMQ Docker container that our catalog service can communicate with. It's time to stand up our RabbitMQ message broker. And of course, we'll use Docker for that. So here I am in Visual Studio Code. And what I'll do is I'll open our play.infra directory. So play.infra, and then I'll do code.-r. And here, I'll just go ahead and close this, close that, and I'll open our Docker Compose YAML file. And perhaps I'll collapse this. So the first thing that I'll do is I'll go ahead and remove this comment that we had at the top. And now we can go ahead and start declaring our RabbitMQ service. So just like we did with Mongo, we'll come here and we will declare a service for RabbitMQ. Let's name it RabbitMQ. And then, as usual, the first thing that we want to declare here is the image that we're going to use. That image is in this case is going to be the standard RabbitMQ image. That includes also a portal to manage the RabbitMQ infrastructure. So that will be RabbitMQ management. Then we will mention the container name, the name that we're going to give to this container, and it's just going to be RabbitMQ. Then we'll go for the ports section. We're going to open two ports. One port for our services to communicate with RabbitMQ, and then another port for us to be able to navigate to the RabbitMQ portal. So the first port is going to be 5672, maps to the same one internally, and the other port is going to be 15672, which maps to the same port internally too. So the first one is going to be used by the services to publish messages to, or to consume messages from RabbitMQ, and the second one is going to be used to be able to go to the portal, to the RabbitMQ portal. Then we're going to go to the volume section, and we're going to declare a volume also for RabbitMQ, which is important because we don't want to be missing those messages if the RabbitMQ container goes down. So I'll just declare RabbitMQ data. And now we have to map that volume into some location in our RabbitMQ image or container. So I'll declare volumes. We'll copy RabbitMQ data. And the location that you want to map inside RabbitMQ is going to be var lib RabbitMQ. And one more thing that we have to specify here, which is pretty important, is the host name. So host name, and we will give it the value of RabbitMQ. So this one here is pretty important because this is associated to how RabbitMQ stores data internally. And if you don't specify it, then it gets a random value, and then each time we restart the container, RabbitMQ would store data in a different place, which is not going to help us really a lot. So keep in mind, you always want to specify here. It doesn't matter what value you use here, but you have to specify some value. Okay, so with that done, I'll do Ctrl+S to save this file. And then I'll open the terminal. And it's time to start this container via docker compose up-d. Hit enter. And since this is the first time that I'm pulling in the RabbitMQ image, so you have to download it to my machine. Like I said, next time it will be faster. So yeah, now we have RabbitMQ up and running over here. And with that, we can start trying this out. So I'll go back to our catalog project. And here we're going to start the catalog web server, but we'll do it via .NET Run so that we can take a closer look at what's happening behind the scenes. So I have opened the terminal, Ctrl+J, then I'll do src, and then I'll do catalog.service. And then let's just do .NET Run here. I'm going to collapse this also. And so a couple of things to notice here is that, so yeah, mass transit is doing its job. It's starting the bus, and then it has connected to RabbitMQ in port 5672 using the protocol AMQP. So here's where you can see the actual address of RabbitMQ in the Docker container. Like I said, this is the one port to connect to the queues. And so things are looking ready on this side. So now we'll go to Postman. And what I'll do is I'll go ahead and I will create an item in our catalog. So I'll go to our catalog API, and I'll open the post one. And here I'll create some new item. Let's say this time we're going to create an antidote. So antidote, cures poison, and then price is going to be 7. And I'll hit send. So that item got created in the database. But now let's see what else happened. So if we see now here, yeah, the item got created, but also an exchange was created in RabbitMQ. So mass transit created this exchange in RabbitMQ for us. That's one of the nice things about mass transit, so we don't have to create it manually. And it got the name play catalog contracts, and then the name will be catalog item created. So an exchange will be created for each of the messages that we publish from catalog. And you can see that after creating the exchange, it also sent the message to that exchange. The message was sent over there. And so if you want to see how this looks like in RabbitMQ, actually, we can go ahead and check out the RabbitMQ portal. So let's open that portal now. Here we are in the browser. Let's go to localhost 15672 is the place. And here we're going to use just the default username and password for RabbitMQ. So that's going to be guest, and it's exactly the same password, just guest, login. And in this UI, you can see a bunch of things, but really the one thing that I wanted to show you now is the exchanges. And as you can see, there is a exchange created here, catalog item created, and is of type fan out, meaning that anybody listening to this exchange will be able to get the messages. And then catalog item created, I'll go in there, and then there's not much to see here because the exchange just takes messages from one place to the other. It's not going to store the messages. And then as you can see, the exchange right here in binding section, it is not connected to any, it doesn't have any bindings just yet. And that's because we don't have a consumer of these messages yet, which is going to be inventory. And but it's not there yet, so the queue has not been created. And so there's no destination for these messages just yet. And so at this point, we are able to publish messages from our catalog service anytime our items database is updated. So in the next lesson, we will generalize some of the code that we have added here into our common library in preparation for having inventory start consuming the published messages. Let's move the code that configures mass transit and RabbitMQ into our common library so that things get easier and cleaner for catalog and any future microservices. So here I am back in our catalog project, and I'll start by going to our settings folder, and I will copy our RabbitMQ settings file, copy that, and then I'll switch to our common project, our common library. I'll open our settings folder and I'll paste the copied class. And I'll grab the namespace from some other of our settings classes. I'll just fix that namespace here. Save. And now, before adding the mass transit classes, let's bring in the NuGet packages that we're going to need over here. So I'll do Ctrl-J. Let's go into source, play.common. And let's add the same NuGet packages that we already added into catalog. So .NET add package, mass transit, .ASP.NET Core. And then let's do mass transit RabbitMQ. All right. So with that done, let's go ahead and create a new folder. Let's call it mass transit. And perhaps let's close this terminal for now. And just like we did with MongoDB, let's add an extensions file here, where we're going to add our handy extension method. So let's first declare a namespace. Play.common.mass transit. And now let's create our class. This should be a static class. And now we'll bring in our extension method. So this is going to be public static iService collection add mass transit with RabbitMQ. So that way we can do all the registration for mass transit and RabbitMQ in one location. Let's add the missing namespace and let's extend iService collection services. And here is where we're going to bring that code from the catalog service. So I'm going back to catalog, into the startup class, scrolling down, I'll copy these lines, copy that into common, and I'll paste them over here. And now let's start fixing all these missing namespaces. So add mass transit, we need to import using mass transit. And then for RabbitMQ settings, we'll need to import play.common.settings. Kvat case endpoint name formatter, we'll need mass transit.definition. Okay, and just like before, we also will need an actual instance of the configuration class and an instance of our service settings class. Now these are very similar to what we did in MongoDB. So let's see if we can get something from there. So MongoDB extensions, let's see, let's grab these two lines. Let's close this and into this spot there. And let me collapse this navigation pane now. So here we also need an import for iConfiguration. Let's grab that, extensions configuration. And you can notice that there's no service provider variable available here. However, we do have a service provider, and that is this context class that's over here. This iBus registration context is actually a service provider. So we'll use that as the class that can give us an instance of iConfiguration. We can also fix this other configuration member here. And let's also rename this X variable here to something more meaningful. Let's name it configure. And since we are here, one more thing that we can do is to perform the consumers registration. The consumers are the classes that are in charge of consuming messages from the RabbitMQ message queues. We have not created these classes just yet for catalog because catalog is not consuming but just polishing messages, but we will create these classes in inventory. So since inventory will be using this method, we might as well just add that registration over here. So I'll open a couple of lines here, and what I'll do is I'll just say configure.addConsumers, And there's a few ways to register consumers. The way we're going to do it is that we're going to specify the assembly that should have all the consumers already defined. And that's going to be the entry assembly for whichever microservice is invoking this class. So to get that, we're going to say assembly, and we need another import here using system reflection that get entry assembly, and that should do it. Okay, so any consumer classes that are in that assembly will be registered by this method. And finally, let's go ahead and return our services instance to complete this method. Okay, so with that, let's make sure everything is built in. So I'll do Ctrl+Shift+B. And yep, everything builds just fine. And now let's go ahead and package all these new changes into a new version of our NuGet package. So let's go back into our PowerShell terminal, and perhaps I'll clean this. And just like we did before, we're going to do .NET Pack, but this time we're going to specify a version. Last time we didn't do it, and that generated version 1.0.0 for package. This time we need to increase the version so that our consumers can actually notice that there's something new available in the package. So to specify a version, what you can do is use the -p parameter, and then you specify package version, and then you specify the version. So I'll say 1.0.1. And then just like before, we'll specify an output directory. It's going to be the same location as before. Packages, enter. And we got a new NuGet package created right there. So now let's go back to our catalog project and start taking advantage of this package. And first thing I'll do is I'll delete our settings directory once again. We don't need it. Get rid of it. Then I'll go to our project file. And since we're bringing in this NuGet package that has all the mass transit stuff, we should not need these two references. So I'm going to get rid of them. Save. And now what I'll do is I'll just go to our play.common dependency, and I'm going to bump the version number here. This is 1.0.0, bumping it to 1.0.1. I'll hit save. This pop-up dialog shows up asking us to resolve the updated dependencies. So I'll click on restore. And that's going to bring in the updated package into catalog. So I'll close this and I'll close that. And now it's time to update our startup class to take advantage of the new package. First, let's get rid of this unneeded import at the top. And now what we can do is just, since it's Fluent, let's expand on top of our add Mongo repository. So let's just do add mass transit with RabbitMQ. We may be missing a namespace, so we need to import play.common.masstransit, and then that becomes the one line that we have to run to execute all this stuff that we were doing before. So I'll get rid of all these lines, save, and that should be good enough. I'll do a Ctrl+Shift+V to make sure that things are compiling. Yep, it's looking good. So let's go back, let's open a new terminal here. And let's verify that things keep working properly. So I'll go to src. Oops, not into contracts. We want to go into service. And then I'll do .NET run. Yep. So yeah, we are connected. We have connected to RabbitMQ. So it's time to do something about messaging. So let's go back to Postman. And last time we had created this antidote item, and so instead of creating a new one, why not let's try an update operation, so a put. So I'm going to just copy this, and then let's go into put, and then in the body we're going to just paste this. So it's the same antidote, curse poison, but let's say that the price is now 9, and then let's bring the ID. Hopefully it's the same ID that we used before. So I'll copy this ID into the URL for the put operation, and then I'll hit send. So we got 204, so it was a success. And now let's go back to VS Code. And yeah, just like before, the exchange was declared and the message was sent to the exchange, as you can see. But this time we should have a new exchange. So let's go back to RabbitMQ briefly. And here, let's go now to exchanges. And as you can see, there's a new exchange here, catalog item updated. So things are working properly. And one last thing that we have to do here is to actually publish the catalog contracts as a NuGet package so that inventory can use it in the next lesson. So let's go ahead and go back to catalog. And here I am. I'm going to do Control-C in my terminal so that the host stops. And then I'll switch to our play.catalog.contracts directory. And here I'll do what we did before. So .NET pack, and then output directory, packages. So that should go ahead and produce our contracts package. Hit enter, and there it is. So now we have a contracts package that inventory service will be able to use to consume the messages. In the next lesson, we will update our inventory service so that it can consume the messages published by catalog. The whole point of moving inventory to using asynchronous communication is to have its own database of catalog items that it can use without ever having to get in touch with the catalog service API. Therefore, let's start by defining the entity that represents catalog items in the inventory microservice. So here I am back in our play.inventory microservice, and I'll open our entities directory. Now this new entity that we're going to create has some similarities with inventory items, so I'm actually going to start by getting a copy of inventory item. So I'll just copy this and I'll paste it right there. And let's rename this into catalog item. Catalog item, and we rename this as catalog item, which also implements iEntity. But in this case, it's not going to have most of these properties, but it's only going to reuse the ID. Now, as you remember, the catalog item has a bunch of properties in the catalog service, but here we will only introduce the properties that make sense for inventory. So in this case, this is going to be, we'll start with the name, and then we will also need description. Okay, so keep in mind that as you are bringing in these entities from other microservices, you don't have to have everything that these entities have in the other service. It's only the version that the new microservice needs. In this case, just ID, name, and description. With that done, let's go ahead and start bringing in the NuGet packages that we need for this. So I'll go to play.inventory.service csproc, and then I'll open my terminal. So let's go to src inventory service, play inventory service, and let's get a reference to our new catalog contracts NuGet package. So .NET add package, play.catalog.contracts. Remember, this has all the contracts that we can use to consume messages from catalog. Okay, with that done, let me close this, and now you can see that we have play catalog contracts here. But we also need to bump the version of play.com because remember we added some new classes in there. So I'll bump from version 1.0.0 to version 1.0.1. I'll save that. Let's go ahead and restore the new NuGet package. And now we can close this. Close these files. Now it is time to define the consumers. And like I said before, the consumers are the classes in charge of consuming the messages that have been published by any other microservice. So to define the consumers, let's go ahead and create a new folder. Let's call it consumers. And we have to create one consumer for each of the different operations that happen in catalog. So that's for creation, update, and delete of catalog items. So I'll go ahead and create a new file. Let's name this one catalog item created consumer. I'll copy the name. Let's give it a namespace. Service consumers. Okay, so this is our catalog item created consumer. And the first thing that you have to do about this consumers class is to make sure that they are actually consumers. And to do that, you have to implement the iConsumer interface, which is part of mass transit. And I'll do control dot, so using mass transit. And here you also have to specify what is the type of message that this consumer is going to handle. And that type of message is actually coming from the the contracts that we're bringing in from catalog. So in this case, it's going to be catalog item created. See if we're missing something, using play.catalog.contracts. So then let's go ahead and implement this interface. So I'll do control dot here, implement interface. And as you can see, we just have to implement one method, which is the consume method. So which is where we're going to actually perform the action of consuming the message. And so what we want to do when we consume the message is actually store it in our local catalog items database. So to do that, let's first introduce a repository that we can use for that. So I'll declare read-only iRepository of type catalog item. Okay, so this is the new entity we just introduced for catalog items in inventory. All right, see if we're missing something. Play that common for iRepository and play that inventory service entities. And now we need to inject this repository in the constructor of this class. So let's define a constructor. So public catalog item created consumer. And so here's where the repository comes in. Okay, so let's say this repository equal repository. Let's now go ahead and implement the consume method for this class. So I'll get rid of this, and let's first get a copy of the message. So the message that we're receiving is available in the context variable as the message property. So let's grab that copy there. And then what we want to do as we consume this message is probably first make sure that we have not consumed this already, right? We may have already consumed a message of the creation of an item with the ID that we're going to get in this message. And if we did, we already would have that into the database. So let's make sure that we don't have it. And if we do have it, let's just return. There's nothing else to do. But if we don't have it, we'll go ahead and create it. So let's see. Item is await repository get async, and that's going to be in message dot item ID. Let's also make sure that this method is async. And then if item is not null, then we will go ahead and return. Okay, because in this case, it happens to be that we already created this item in our local database, so why would we create it again? If not, we will say new catalog item, and then we'll say all these message.item ID, name is message.name, and description is message.description. Finally, we'll go ahead and do repository.createAsync of this item. Okay, so that's all you have to do to consume a message that represents a new item that has been created in the catalog. Like I said, we just verify if the item is already here, because it could happen in the cases where for some reason the publisher publishes the same message twice. And so we don't want to be having errors here because we already have the item in our catalog items database. So if we don't have it, we will go ahead and define it and create it into our local database. Let's go ahead and do something similar for our updates. So when a catalog item has been updated. So I'll get a copy of the consumer, and let's just rename it into catalog item updated consumer. Okay, so I'll do this, and then the message is catalog item updated. Okay, so let's fix a couple of things. Constructor there. Okay, so we are consuming now catalog item updated, and here the logic is going to be a little bit different. So but for an update, it could be that we already have this inventory item in our local database. So in which case we'll need to go ahead and just update the properties. Or it could be that this is the first time that we receive this the message for this item, in which case we'll go ahead and create it. So now in the case that, so first, just as before, we can go ahead and get the item, but if the item is null, so we'll change this, if item equals null, Then we will go ahead and define these lines that we had over here. There. So if the item is null, we don't have it in the database, so let's go ahead and create it. Otherwise, let's just update the properties that make sense. In this case, it's going to be item.name equals message.name, and item.description equals message.description. And in this case, let's go ahead and call await repository dot update async item. Okay, so quick recap, for an update operation, we go ahead, find the item. If we cannot find it, we will go ahead and create it into the database. And if we find it, we update name as description and update it into the database. Now let's go ahead and implement our third consumer, which is going to be for deleted items. So again, I'll get a copy of this last consumer, paste here, and let's rename it into catalog item deleted consumer. I'll copy this name. So I'll update the name of the class, the constructor, and then let's make sure we also update the message that we're handling here. This is catalog item deleted. Here and there. And in this case, things are even easier. And so we will go ahead, we'll try to find the item, and if we cannot find it, it means that for some reason it does not exist in our local database, so there's really not much more to do in our case. So we will go ahead and just return. We don't have it, just go ahead and return. And if we have the item, then we can go ahead and say await repository remove async message.item ID. Okay, so with that, we have our three consumers defined. And now it's time to perform the proper registration in Startup. And before we can do that, let me go to app settings.json, and we need to declare those RabbitMQ settings so that we know how to communicate to RabbitMQ. So I'll actually go back to catalog, our catalog service over here, and I'll just grab those three lines for RabbitMQ settings from app settings.json, and then back to inventory, we will add that over here. Same thing, we're talking to localhost for RabbitMQ. Now let's go to Startup. Okay, perhaps I'll collapse this for a moment. So let's do a few things here. So as you see, we still have this logic to use the catalog client to talk to the catalog service. We will not be using this anymore, but let's keep this logic around in case you want to reference it later. But what we're going to do is we're just going to refactor it into another method so that we don't have to have all this stuff hanging around here. So I just selected all this logic to use the the retries and the configuration of the client. I'll do control dot and I'll say extract method. So we'll name this method add catalog client, and I'll take this method and just send it to the end of the file so that we don't have to see it frequently. And now a couple of things that we have to do here for our new catalog items repository and mass transit. So first, we need to introduce a new repository here for the catalog items. So I'll say add Mongo repository, catalog item. And then we need to give a new name for this new collection of items. In this case, it's going to be catalog items. Okay, so keep in mind that both of these are going to live in the same database, the same inventory database, but it's two collections, one collection for inventory items and one collection for catalog items. And then we also need to add the mass transit registration. So I'll say add mass transit with RabbitMQ. Let's add a missing namespace. And that's pretty much it on startup. Then let's go back to our Explorer. One more thing that I'll do is just like we did in catalog, let's flip the default log level so that we can see also what's going on regarding all these message exchanges. So I'll change this to debug. And with that, our inventory service is ready to start consuming messages. But one more thing that I'd like to do is to actually clean up our databases. And I'd like to do this because at this point, we do have some data, both in inventory and in catalog side, but that data has never been synchronized at all. So it will be better to just start clean in a situation where both sides are actually synchronized from the start. So I'll go back to MongoDB, the MongoDB extension. I'll expand this. And as you can see, we do have the catalog and inventory databases. So to clean them up, I'll just right click and say drop database. I'll drop catalog. And then I'll drop inventory. You may choose to not delete them, but that could cause issues as you start moving forward. So it's better to just start clean in this case. At this point, I'll start our microservices. So I'll do Ctrl-J to open the terminal. I'll go to my terminal. And perhaps I'll do clean. And just so that we can see things better, what I'll do is I'll collapse this and I'll bring in yet another terminal with the split terminal button here so that we can see services in both sides. So perhaps what I'll do is I'll switch to a catalog on the left side. So I'll go to play that catalog and then play catalog service. And on the right side, I'll stay in inventory. So I'll do play inventory service. Okay, so let's clean both sides. And now we can start both services. I'll do .NET run both sides. And now notice in the right side that a few new things are happening. And perhaps I'll move these around a little bit. And yeah, it may be a bit hard to see, but exchanges has been declared for the consumers that we declared here. You can see we have exchanges for a catalog item created, updated, and deleted. And if we scroll down a little bit, let's see. These exchanges are now connected to the queues. So you can see that this exchange is now connected to our new inventory catalog item updated queue, same for created and deleted. And the consumers are reporting that they are okay. So they're ready to start consuming messages. Okay, so let's move this over here. So now let's see this in action. So let's go to Postman. And what I'll do is I'll start by creating a brand new item. So I'll go to our post item API in play catalog service, body. And let's define our classic potion example again. So we'll say potion stores a small amount of HP and the price is going to be 5. I'll go ahead and hit send. The item has been created. And then let's go back to our terminals and see what happened. So as you can see on the left side, the exchange was declared, catalog item created, and the message was sent, right? So catalog item created was sent. And then on the right side, we can see that now we actually received the message and that was handled by the catalog item created consumer. So if things went correctly, we should now have a copy of the catalog item in our local catalog items collection in the inventory side, inventory database. So let's go to MongoDB. And let's see what we have. So I'll expand this. So we have the catalog database with this item created here. And then we'll expand inventory. And then you can see that we do have now our catalog items collection with that item created over here. So the item has been replicated from catalog into inventory. We can now take a look also at the activity that happened in RabbitMQ. So let me go to the RabbitMQ portal over here. And let's take a look at exchanges. So see that we now have the 3 exchanges for catalog item created, deleted, and updated from the catalog side. And then also the exchanges from the inventory side. Created, deleted, and updated. And then if we go to queues, you can see that now we have the 3 queues for the 3 types of events. And if we go to catalog item created, we could see here any activity that goes across this queue. Now the item has been already consumed, so there's not much to see here. But let's see what happens in a case where, let's say that our catalog service is not running, right? So actually our inventory service is not running. So our catalog service publishes some message, but inventory is not running. Now that the queue is up and running, things are going to work in a bit of a different way. So let's go back to inventory, and I'm going to stop the terminal on the right side. Just going to do Control-C. Inventory is stopped now. And let's go back to Postman and create yet another item. So I'll create an antidote, which cures poison, and price is going to be 7. So I'll go ahead and post this. And then if we go back to RabbitMQ, let's see, catalog item created. You can see that now there is one item in the queue, as reflected by this. As you can see, it's one item, which is waiting to be consumed by somebody. So here is where the nice thing about asynchronous communication starts happening. So there's no need for catalog to be up and running all the time. Inventory can nicely just keep publishing these updates to their items, and then whenever inventory comes back, it should be able to consume the message. And in fact, let's go back to our terminals right here. You can see that the catalog item was created on the left side. And now let's go ahead and start a terminal on the right side. Let me collapse this once again. Okay, so on the right side, I'm going to do .NET run again. And then you can see that right away, inventory is able to consume the new message. So the databases should be in sync again. We can see that there's no more messages here waiting. The message was consumed. And our databases should be once again in sync. Let me refresh this. So yeah, we have 2 documents here, and we have 2 documents over there. So things are in sync. So our inventories microservice now have a nice way to stay in sync with any updates to the items managed by the catalog microservice. In the next lesson, we will update inventory so that it starts taking advantage of this new capability anytime it needs to present data that is partially coming from catalog. Now that our inventory microservice has its own copy of the catalog items, it no longer needs to query the catalog microservice to gather additional information about the items of inventory. So let's update our inventory controller to take advantage of its new catalog items collection. So here we're back in our inventory project, and I'll go ahead and open our controllers folder, and I'll go to items controller. Let's collapse the navigation pane to get more space, and let me scroll down a little bit. And the first thing that we'll do is to get rid of our catalog client, because we will no longer need to invoke the catalog service anymore. Instead of that, we're going to declare another variable here, which is going to be just another iRepository. But in this case, it's going to be of catalog item. So this is going to be our catalog items repository. As we're introducing this new repository, let's also rename the previous one so that it better resembles its purpose. So this is going to be our inventory items repository. Let's also rename this the variables in constructor. So this items repository becomes inventory items repository. And then it's time to inject also our new catalog items repository as opposed to the catalog client. Here we will capture that. So with that, let's go down into our getAsync method. And here's what we're going to do. The first thing is that we definitely don't need to call catalog client anymore. So we're going to get rid of this. We still need to get the list of all the inventory item entities that represent the items in the user's inventory. So this stays. But after that, what we want to get is from our local catalog items collection, we want to get all the corresponding catalog items that, the ones that correspond to the inventory items on inventory, to the items on inventory. So to get that, let's first get all the list of all the catalog item IDs that are involved in the inventory items collection that we have here. So to do that, let's do this. So item IDs equals inventory item entities select. Let's do a little projection here where item dot catalog item ID. Those gives us the list of all the catalog items that we have in inventory, the IDs specifically. And with that, we can go ahead and get the actual catalog items. So let's do catalog item entities is await catalog items repository, get all async where item. And here we're going to say is that we want to get all the items that are in the item IDs collection. So I'm going to say item IDs contains item.id. So now here we have all the catalog items that match the items that we have in inventory for the current user. Having that, we can go ahead and update this little function here so that I take advantages of this new items collection. So now I'll say catalog item entities is going to go here. So now we can go ahead and say, okay, so as we go through all the inventory items, first we're going to look at the catalog item entities and we're going to find the catalog item whose ID matches the ID of the catalog item ID of the inventory that we're looking at. So that's the catalog item. And then we'll keep moving forward as usual. And we say, okay, so now that we found the inventory item and now that we have the catalog item, let's go ahead and turn it into a DTO, adding the catalog item name and the catalog item description. Okay, so I don't think we need to make more changes to post async. So we should be ready to start using this. So I'll save this. I'll go back to catalog. I'll just going to hit F5 to start the service. And I'll go back to inventory and I'll do the same, F5 to start the service. And now let's go ahead and go back to Postman and let's grant one item to our user. So the first thing that we'll do is actually get the list of current items in our catalog to know what to grant. So I'll just open our get operation in the catalog service and I'll hit send. Here we are. We have currently a potion and an antidote. So let's say we want to do the potion. So I'll copy the ID of the potion. And now let's go to the inventory collection. Let's expand this. And I'll go to our post operation where we can assign one item to a user. So I'll go to body. I'll paste the catalog item ID that we just copied over here. So this is the item to assign. And then just like before, we need a user ID. So just as we did before, let's use the Postman function, GUID, to generate a random user ID. And finally, let's get some quantity. Let's say we're going to assign one potion to this user. Okay, and so with that, I'll go ahead and post that, send, and it's done. And if it worked, now our user should have one potion, right? So I'll go ahead and first we need to figure out what's the ID of the user that was generated. And we can do that from the console. So I'll click on the console and I'll go down to our post operation, request body, and it's right here. This is the user ID that was generated. I'll copy that, close console, and then we can go to our get operation to get all the users in the, all the items in the user's inventory. And so we'll get the items for this user. I'll hit send. And as you can see, now we can see that this user has a potion, has one potion, but more interestingly, it is able to show the name and the description of the potion from the local catalog items collection. So it no longer needed to go ahead and talk to the catalog microservice to retrieve the additional information. So things are much more resilient and faster now because we don't need to go out and ask for this additional info. Now, what would happen if we go ahead and update the description of this catalog item in the catalog microservice? How would that look like here? Let's try that out. So first I'll go back to our get items results, and I'll copy a few details about the potion. I'll just copy that, and then I'll go to the catalog collection and I'll go to the put operation. Here's where we can make updates to our item. So I'll just come here, paste that, fix indentation, and let's say that instead of having this description, it just says restores some HP. That's going to be the new description. Also, the ID of this item is this one here. So let me grab it, go back to put, I'll paste that here. And so let's go ahead and update this item in the catalog microservice. So I'll go ahead and do that. And then I'll go back to our query for the inventory items of the user, and let's see what happens with the description of this item. So I'll hit send, and as you can see, the description is already updated. And this is because as soon as we updated the item in catalog microservice, a message was published into RabbitMQ, and then our inventory service grabbed that update into its local database and is ready to present the updated description as we query for items. So this is great. But now, what would happen if our catalog microservice is having issues? Actually, what happens if it's completely down, right? So it has a major problem. What would happen with an inventory microservice? Can it still keep working just fine? Let's see. I'll go back to catalog. Here's catalog. I'm just going to stop the service. So the service is completely down. And in fact, if we go back to Postman and we try to get items again, let's see what happens. Yep, connection refused because the service is completely down. But then let's try to get all the items on the user's inventory. So I'll hit send, and it still works. Even more, I can try granting yet another item to the user's inventory. So just to test this out, I'm going to start catalog once again, hit F5, back to Postman. Let's go ahead and get the list of items. And now I'm going to grant the antidote to that same user. So let's do antidote into the post operation body. So let's grant the antidote. Let's make sure we use the same user ID. It's right here. The user ID. And then again, like I said, catalog is having problems. I'll just stop it. It's completely down. It's not working. Yet I'm going to go ahead and grant an item to the user. I'll hit send. 200 OK, so it looks like it was successful. And then let's get all the items in inventory now. So I'll hit send again over here. And as you can see, we can query for all the items, and all the items are showing name and description, regardless of the fact that the catalog microservice is completely down. So this is the power of asynchronous communication, and this is how you enable very resilient communication between microservices. Both services are now really autonomous because they don't rely on each other to be available at any given time. One more thing to consider is the case where one of our consumers is not able to consume the message properly, perhaps due to some issue when trying to talk to its local database. So for instance, let's go to our inventory service over here, and I'm going to stop this for now and close terminal. And I'll go here into our consumers, let's say catalog item created consumer, and what would happen if this line here is having trouble, right? So when we go into the consumer, all this logic happens because we are consuming the message. But if we fail, if an exception is thrown in this case, the message is going to be sent into some error queue, and you will not be able to consume it anymore. So at that point, you missed an update from the catalog microservice. So is there a good way to handle this? So it turns to be that, yeah, there's a way to do that. So if you go back to our common library, so here we are back in common library, and I'm going to go to the mass transit extension that we created before and scroll down a bit. And what we can do is to enable, and I'll close this, we can do is enable message retries for the consumption of the messages. So you can go here and say configurator that use message retry, and then here we're going to define our retry configurator. Okay, let's open this section. And then you can say retry configurator that interval. And then the first parameter you're going to specify is how many times you want to retry. So anytime the consumer is not able to consume the message, how many times you want to retry that consumption. So let's say we want to say 3. And then you have to define the time span or our time between retries. Let's say that's going to be time span. Let's import missing namespace from seconds, and that's going to be 5 seconds. Let's also import another missing namespace. We need to use using green pipes here. And that's all it is. So with that logic, anytime a message is not able to be consumed by the consumer, it will be retried 3 times and with a 5 seconds delay in there. And there's a bunch of different ways to configure this depending on how you want to do your retries. And with that, let's just save extensions. And then if you wanted to consume this in your microservices, as usual, you will go ahead and generate another version of the NuGet package. So in this case, it would be, you would just do .NET Pack. It would be package version. Let's say in this case would be 102. And then we send it to the same location as before. Packages. Package generated. And then you would just go back to catalog and update its version over here to play that common 102. Save. Restore dependencies. And then we would go back to inventory and do the same thing. 102, save. And then we'll not exercise this really in this lesson and restore, but that's how you do it. So from here on, both microservices have this capability to retry the consumption of the messages. So that marks the end of this lesson and of this model. You now have 2 independent and resilient microservices that can collaborate asynchronously to manage a catalog of items and to grant and query for items in a user's inventory bag. You also have a reusable common library that any of your future microservices can take advantage of and that you can keep improving according to your needs. And along the way, you have learned how to use multiple microservices patterns and techniques, the .NET Platform, VS Code, Docker, MongoDB, NuGet, RabbitMQ, and Mass Transit to quickly and reliably stand up new microservices to further expand the capabilities of your system. I hope you have enjoyed the ride. In this model, you will connect the provided front-end project to your microservices to enable basic end-to-end scenarios from a modern single-page application. By the end of this model, you will have a solid understanding of the following: how to get and build the front-end project in your box, how to host the front-end project in a Node.js server, what is the structure of the React-based front-end, what is CORS and how to configure it in your microservices, and how to debug the communication between the front end and your microservices. In terms of our overall system design, this model is all about the front-end single-page application. You will see in detail how the front end interacts with all the REST APIs provided by the catalog and inventory microservices. Also, at this point, the front end will talk directly to the microservices, which is not ideal, but we will do it this way for now, just so that you can focus on the front-end to microservices communication aspects, without the complexity of the introduction of an API gateway. Let's get started. In this lesson, you will install Node.js, which is a JavaScript runtime that will host the front-end portal, and that also includes npm, the package manager that provides all the dependencies required by the portal. The only additional tool required to build and launch the front-end portal is Node.js, which you can get in the nodejs.org website. Let's see how to install Node.js and verify the installation afterwards. Before installing Node.js, just keep in mind that the pages that you will see next will likely look a bit different depending on your operating system and the versions available at the time that you're taking this course. But regardless, the overall download and installation process should be mostly the same. So let's now browse to the Node.js website. And here, the first thing that you're going to see is right away a few download buttons for your current operating system version and architecture. In my case, that will be for Windows 10 x64. These are the 2 versions. The one on the left is the most stable version available, and the one on the right is the latest version available, which may not be the most stable one, but it has the latest features. I would recommend going for the most stable version, the LTS version, since that's a recommended one for most users. Now, if the version that you would like to download is not here, you can always go to the other downloads link over here. And here you can pick the right version for your operating system. And you also have a few other download options. Now in my case, I'm going to go back to the first page, and I'm going to download 14.17.0 LTS. So I'll just click there. And now I'll go ahead and start the installer. So I'll click here. Here's the installer. So I'll just click next, accept, next, next, and next. And at least for this course, I have not seen the need to install any additional tools here. So I'll just click next and install to get the installation started. Say yes. And so with that, Node.js is installed in the box. So I'll click finish. And what we want to do now is to verify that the installation has completed properly. So what I'll do is I'll just close the browser now, and I'll open my Visual Studio Code instance here. And here in Visual Studio Code, what I'll do is I'll open my terminal by pressing Ctrl+J. And I'll just type a couple of commands to verify that the tools are installed properly. So I'll just type node-v to get the version of Node.js, which you can see right there, 14.17.0. And now also verify the version of npm, which is the package manager that comes with Node.js. So I'll do npm-v, and I can see the version right there also. So with this, we know that Node.js has been properly installed and we're ready to move on. In the next lesson, you will learn how to get all the included source code for the front-end portal. In this lesson, you will explore the structure of the front-end code base, how to install its dependencies, and how to build and run the portal. Before exploring the front-end code base, let me give you a few details about it. The front-end is a simple, single-page application that demonstrates one way to interact with all the Play Economy microservices. A single-page application is a web application that dynamically rewrites the current web page with new data from a server, instead of constantly loading new pages. It is built using React, which is a JavaScript library for building interactive user interfaces. I chose React because at the time of creating the course, it was one of the most popular front-end frameworks and is easy to learn, assuming that you have worked with JavaScript before. It uses Create React App to simplify how you do local development, how you build and debug the code in your box, and how you package everything in preparation for deployment. Finally, it is hosted in a Node.js server, a very popular runtime for JavaScript applications. There are a few things that I'd like you to keep in mind as you work with the provided front-end portal in this and the next lessons. This is not a course about front-end development, and certainly not about React. As a back-end developer myself, I only know enough React to build this simple portal. However, I'm probably making lots of beginner mistakes, and I'm probably not following client-side best practices in many places. So please don't use this code as a template for the production-level application, but more as a basic example of one way you could interact with the microservices from a modern client. You won't be coding this front end in this course. There is both not enough time, and I'm not qualified to teach you how to build a front end step by step. Instead, I'm providing you the finished portal so you can use it as is. It should work with no issues and no changes required, provided that you make a small update to the microservices, as I'll explain in the next lesson. In this lesson, I'll give you a quick overview of the structure of the front-end code base, with a focus on the areas that interact with your microservices, as opposed to the many components that handle layout, rendering, and many other things. Finally, please check out the links below if you would like to know more about the tech used in the front-end project. So here I am in a new Visual Studio Code instance, and I have already opened my terminal into the projects directory where I have all my files. And as you can see, I have already downloaded and extracted the front-end project files into this directory, play.frontend. And what I'm going to do now is just switch to that directory. And I'm going to open this instance of code into that directory by doing code.-r to reuse the window, enter. And here you can see the structure of the project files on the left side. And what I'm going to do is first close this terminal for a moment. I'd like to point you to the readme.md file. So this is a file that will give you a description of what this project is about and a few other things. And in fact, what you can do is just open this preview window with this button that opens a preview on the right side. I'll close the original one. So this gives you a nice view of the readme file. So as you can see, this describes the project, it describes the prerequisites of the project, and then it tells you how to build the project, how to run it locally, and also it provides a bunch of other scripts that are also available. Now, what we're going to do is to actually follow these couple of first lines in this file to get started with the front end. So as it says, what you can do to install all the dependencies of this front end is run just npm install. So I'll open my terminal once again. Right here, scroll down a bit. And what you want to type just at the root of this project is npm install. Hit enter. What this is going to do is to bring in a bunch of node models that represent all the dependencies that this portal depends on, including React, Bootstrap, and a bunch of other things. This is going to take a while depending on your internet speed because there's a lot of stuff that needs to get downloaded. So just give it a moment. Okay, so the dependencies have been installed, and as you can see, there's now a node models folder on the left side. If you expand it, you're going to find a bunch of directories have been created. Right? So now that we have that, we are ready to run the portal. So to do that, if you scroll down in the README, you can see that you can just do npm start, and that's what I'm going to do here. Npm start, enter. So this is going to compile the entire code base, and then it's going to start the Node.js host. Okay, so it compiles successfully, and as you can see, we get an address here to browse locally to it. So I'm going to copy this address, localhost 3000, and I'm going to go to my browser. I'm going to paste that there and hit enter. And there it is. The portal is up and running in this box. Now in the home page here, what we have is just a few basic things like the description of the project, and then a couple of links, both to go to the catalog section to get the list of the catalog items, and the inventory section so that you can inspect which are the items that are in the inventory bag of a user. Notice that we also have a navigation bar at the top that takes you either to the home or to the catalog and inventory sections. There's also links here to go to the RabbitMQ portal if you wanted to explore what's going on with the queues. And there's also links here to explore the Swagger UI OpenAPI documentation for both catalog and inventory service. And also a few other things, general links to the different technologies that were used to create the whole system. Now, before we go and dive into the catalog and inventory sections, which are, of course, the most important parts of this portal at this point, let's go back to Visual Studio Code for a moment. And let's explore briefly the files that are available here, just so that you get an idea of how this project is structured. So what I'm going to do is just close this terminal for now and close the README. And the first file that I'm going to show you is package.json. This one here describes all dependencies of this project, which are all the node models that are installed by now. And like I said, these include things like React, being used for all the components, interactive and dynamic components used across the portal, Bootstrap for layout, and a bunch of things for being able to do routes in the client side, the React scripts, which are the ones that we can use to start the portal, and a few other things. And yeah, many other dependencies. Now let me close this and then take a look at the public folder here. This one is the one that defines index.html, which is what we call the page template. So in a single page application, like I think I mentioned before, there's not really a navigation into different pages of a portal. There's no reload of pages. There's just one page, in this case index.html. where all of these dynamic components are loaded and refreshed constantly. And in fact, in this section here, in this div, root, here is where all the JavaScript files or JavaScript content is injected with all the React components. Now this file also references config.js, which happens to be over here. And this is a file where if you're asking where is the addresses of all the microservices, this is the file. So this is where you're going to see the address of the catalog microservice and the address of the inventory microservice right there, as well as the address of the RabbitMQ portal and a few other derived addresses for the items APIs in catalog and inventory. Now the most important directory actually here is the source directory, because this is the one that contains all the React components. So this is pretty much is the heart of the project. This is where the system logic happens. And in this file, if you go to index.js, this is the root where we start rendering React components, and we are asking it to start rendering them in the root div that we just saw in the HTML. This one here, we saw that there's a root div, and that root div is where index.js will get rendered, as you can see right here. And so the first React component that we actually start rendering is this app component over here, which is coming from app.js. This app component defines our app by using first the layout component, which is in charge of rendering the basic layout of the system. As you can see over here, if you expand components, layout.js, this is the one that defines a navigation menu at the top, the container for all the other components in the middle, and then the footer at the bottom. Back to app.js. As you can see, we have layout, and layout defines that inside of layout, we're going to have a component for the home, a component for the catalog, and a component for inventory. So then if we just go into the components directory, we have our catalog file, and this is the one where you can start really seeing interesting things, because this file allows you to communicate to the catalog microservice. To go down into the populate items method over here, you can see that here is where we are actually talking to the catalog microservice, and then we're getting a response from it, and that's the one that we are collecting and setting it into the client-side state that later on, if you see at the bottom, is being rendered as a list, as a table into the page. Okay, and it's the same idea with the inventory.js, which is able to render the items in the inventory bag of a user. We also have a few model files and form files, like item model, which is the one that is used to render the model dialog. So you can go ahead and either create or update an item, and the item form, which is the one that actually shows the form inside that model. And the same way, we have a model for granting items for a user so that it can go into his inventory bag. So a model and a form for that same purpose. And lastly, we have the .vs Code folder, which you should be very familiar with at this point, where we also have a launch.json file, where we define different configurations that you can use to start debugging either the server side or the client side of this portal. So you can see we have a configuration for the server. We have named it server. This is going to be the one that can launch the npm server or the Node.js server, and one configuration for launching the client at the location of the client in the browser. There's also a compound configuration, which I named server client, that can be used to launch both the server and the client at the same time in your local box. Okay, so I'll just close this. So now let's go ahead and try that catalog section. So I'm going to open the terminal once again here. So our front end is still running, but what we may not be running right now is a catalog service. So let me go back to catalog. Here's my catalog code base. So I'll just switch to src, play that catalog service, and then I'll do .NET run. So catalog is now up and running. So let's go back to the portal, the browser. And in order to see the list of catalog items what you can do is either click in catalog in the navigation bar over there, or you can click in this catalog link right here. And I'll click on it, and this should display the list of catalog items, but as you can see, that is not working right now, so we cannot load the items. So there's some problem happening here. And so on the client side, one way that you can tell what's going on is by using the browser developer tools, which usually you can go to by pressing the F12 key, which I'm going to do now, F12, and this opens the developer tools section. Now on this one, there's a bunch of tabs, but the one that you're interested in is in the console tab. So click on console, and this is going to show you what's going on. So as you can see, there's an error, access to fetch at HTTPS localhost 5001 items, which is the address of the catalog microservice, from the origin HTTP localhost 3000, which is the address of this of the front end, has been blocked by CORS, the CORS policy. So no access control allowed origin header is present in request and resource. So what is this CORS thing about? That is going to be actually the focus of the next lesson. So in the next lesson, we will learn about cross-origin resource sharing, also named as CORS, and how it can help us enable the communication between the front end and our microservices. In this lesson, you will learn about cross-origin resource sharing, also known as CORS, what problem it solves, and how it can help us enable the communication between our front-end portal and our microservices. To understand CORS, let's first understand what a cross-origin request is. Let's put our catalog microservice to the side for a moment, and let's imagine that the Node.js web server that is hosting our front end is also the server that hosts the REST APIs to interact with the Mongo database that owns the catalog data. In this scenario, the browser initially navigates to the web server URL to load the front-end homepage. And then, when the catalog section is requested, the browser makes a GET request to the catalog REST API to the same web server URL, to which the server will reply with a JSON representation of the catalog data. The address from which the browser calls the REST API is known as the origin, and is made of the combination of protocol, host, and port, which in this case is HTTP localhost 3000. Notice how the origin in the browser matches exactly the origin of the server that provides the REST API. Let's now go back to our actual scenario, where our catalog microservice hosted in ASP.NET Core's Kestrel web server is the one providing the REST API. Now, when the catalog section is requested in the browser makes a GET request to the REST API at the origin of the catalog microservice, which is HTTPS localhost 5001. Since both the protocol and port of the catalog microservice are different than the one in the browser, this is known as a cross-origin request. The microservice will return the catalog data just as before. But by now, the browser knows that this response comes from a different origin, since it had set the origin header in the request. Therefore, it rejects the response data with a CORS error. This happens because browsers follow what is known as the same origin policy, which states that a web application can only request resources from the same origin the application was loaded from. Browsers enforce this to prevent malicious websites from reading confidential information from other websites. Unfortunately, this is also preventing our front end from reaching the catalog microservice. So how can we fix this? Here's where CORS comes into place. CORS allows a server to indicate any other origins than its own from which a browser should permit loading of resources. Here's how it works. Once again, the browser has loaded the front-end page. Now, the catalog section is requested and a GET request is sent to the catalog microservice. And since catalog is hosted in a different origin, the browser appends the origin header. The difference this time is that the catalog microservice has been configured with the access control allow origin header, which indicates all the other origins that are allowed to call the REST API. In this case, this header has been configured with the origin where the front end is hosted, HTTP localhost 3000. Once catalog sends the items data back to the browser, it appends this header to the response. The browser now compares the value in the origin header it sent to the value in the received access control allow origin header. Since they match, the browser now allows a response data to reach the front end. This works for simple requests like gets, but for post, put, and other methods, things work a bit differently. When a cross-origin request may perform some sort of write operation on the resources owned by the server, like is the case when performing a post, put, or delete request, the request needs to be first pre-flighted. This means that an additional initial request needs to be sent to the server to determine if the actual request is safe to send. Going back to our scenario, imagine we now want to create a new item in the catalog, and therefore our front end will send a post request to the REST API. However, since this is a post of JSON data across origins, the browser automatically sends first a request with the options method. This time not just adding the origin header, but also two other headers called access control request headers and access control request method. Access control request method indicates that when the actual request is sent, it will be a post. And access control request headers tells the server that the request will come with a content type header, in this case. The server should have been configured to respond with corresponding headers to indicate what it allows. The headers returned by the server are access control allow origin, access control allow headers, and access control allow methods. If the values returned in these headers match the values in the headers sent in the request, the browser accepts the post request and submits this original request to the server with the JSON payload of the new item to create. The catalog microservice creates the item and returns the expected 201 status code. As you can see, the key to a successful cross-origin request is in the appropriate course configuration on the microservice that exposes the REST API, since only the microservice can declare the allowed origins. But how do we properly configure cores in ASP.NET Core? That's the focus of the next lesson, where we will add the missing course configuration to both the catalog and inventory microservices. Let's now fix the course-related errors we are getting in the browser by configuring the course middleware in the request pipeline of our microservices. And let's start with the catalog microservice. So I have the catalog codebase open here in Visual Studio Code, and what I'm going to do is open app settings.development.json first. Here I'm going to declare the origin of the front end so that we can properly configure it in startup later. I'm using app settings.development.json and not app settings.json because the origin of the front end is just a development server at this point, and we will not need a course policy for that origin in production. So what I'll do is I'll just open another section here. This is just going to say allowed origin, and that's going to be the address of our front end. So this is HTTP localhost 3000. Now that we have that, let's go into our startup file. And here's where I'm going to collapse the Explorer for a moment. Let's scroll down a bit. And what I'm going to do is define first a constant to represent the name of that setting that we just created. So this is going to be private const string allowed origin setting is going to be the name that we just created over here. I'm going to copy it, allowed origin, right there. And now that we have that, we can actually configure cores. So to configure cores, what you want to do is go down into the configure method, which is where you configure the request processing pipeline. And so, like I said, this is mostly for development scenario at this point, because the front end is a development web server. So what I'm going to do is take advantage of this m.isDevelopment section, which only happens for development scenarios. And I'm going to add another piece over here. So I'm going to say app.useCores. And here we're going to provide the function that configures the course configuration. So I'll do builder, and I'll do this. And then we're going to say builder dot with origins. And here's where we're going to specify that origin, which at this point comes from the configuration data. So it's going to be configuration. And here we're going to pick the right key from the configuration, which in this case is allowed origin setting. So remember that this configuration is the configuration object that has been declared here, right here, it's configuration object, which is populated automatically by the ASP.NET Core runtime. So that configuration object contains all the data at this point of app settings.json and app settings.development.json, including the allowed origin setting. So you can use this to just go ahead and get the key that corresponds to the allowed origin setting that we just declared. So configuration, and then allowed origin setting. So that allows the origin, but we also have to tell it which headers and which methods are allowed from the client side. So to do that, what I'm going to do is just say dot allow any header to allow any of the headers that the client wants to send. And we will say allow any method to allow any of the methods used from the client side, including get, post, put, and all these other verbs. Okay, so with that, we have allowed the front-end origin, and we have said any header and any method should be allowed. Okay, so with that, we should be able to properly invoke the methods in the microservice from the client side. So let me open up my terminal once again, and I'll do .NET run. And then I'll go back to the browser, where, as you remember last time, we did have this course error. So now I'll just refresh the page. And as you can see, things are loading properly. And in fact, if we inspect briefly the network section here, and we inspect the items request that we made right here, you can see that the browser did send the origin header in the request for localhost 3000, and the catalog microservice responded with the access control allow origin header over there, which is why the browser allowed the response. So that's how you configure cores. And since we did this for the catalog microservice, we should do the same thing for the inventory microservice. So let me go back now to our inventory code base, which I have opened here in this other Visual Studio Code instance. And I'm going to do just pretty much the same thing that we just did. So here, and in fact, I'm going to copy a few sections here. So from catalog, I'm going to close the terminal for a moment. I'm just going to copy this allow origin section into inventory, allowed origin. Then back to catalog, I'm going to copy the allowed origin setting from startup. Back into inventory, in startup, at the top, I'm going to place that constant. And then finally, back to catalog, into the configure section, I'm going to copy the use course section here. And back into inventory, I'll collapse this for a moment. In configure, I'm going to add this right there. Okay, so this enables the same configuration for inventory as the one that we have in catalog. So both microservices are properly configured now. So in the next lesson, we will explore in more detail all the scenarios enabled in the front end and how its React components are interacting with the microservices. Let's now explore in more detail all the scenarios enabled in the front end and how its different React components are interacting with the catalog and inventory microservices. So I have stopped all the web servers at this point, both for the microservices and for the front end. They're all stopped because I want to restart them in debug mode. That way we can jump from client to server and see line by line what's going on. So here I am in the catalog microservice codebase, and I'm just going to go ahead and hit F5 to start that web server, and then I'll go to the inventory microservice code instance, and I'll do the same thing, F5. Okay, and now I'll go to our front end, and in this case, instead of typing npm start from the terminal, I'll take advantage of the debug configuration that we have set here. So I'll go to the run and debug section on the activity pane there. And as you can see, we have a few options here. We can debug either server, client, or server client. Server client is the one that I'm actually going to pick so that both the client and the server are started at the same time. So I'll click there. And this is going to bring up the browser right away. However, it may take a while to load while the server is compiling the source code and starting the Node.js server. If we head back here, you can see that the server is getting started, but it may take a while to start. Okay, so as you can see, the server has compiled the source code properly, and it has started a debugging session of the front end in localhost 3000. So now we can go back to the browser, and here we can go ahead and navigate into the catalog section. So I just click there, and then things are loading properly. But how is this communication from the client happening to the server side? So to understand that, what we can do is just head back to play the front end. And what I'll do is I'll open my Explorer on the left side, and I'll collapse the terminal for a moment. And then I'll go into src, components, catalog.js. I'll collapse that. So here, the communication happens in this populate items method over there. First, we call the fetch function, where we talk to the URL of the catalog items API. So I'll talk to the catalog microservice, and then we get a response back from it. The response will tell us the status code if we wanted to inspect that. But this is actually a promise in the JavaScript land. Is called a promise, which means that we will have to invoke the JSON method to actually get the items in this other .10 that we can then take and then put into what we call the state of this page. And then that state is going to later be used into the in the render items table. The items are going to be taken from the state into this method, are received as items, and then we will just render them in a normal HTML table. So let me put a few breakpoints back into populate items so that we can see things as they go. So I'll place these breakpoints over there. And let's also go to the catalog microservice so that we can put a breakpoint on the server side. So I'll collapse this, and I'll go to items controller, collapse that. And then here we can go into the get async method, put a breakpoint there. So now let's go back to the browser and let's just refresh this page. And sure enough, here back into the front end, we have hit the breakpoint. And as you can see, here's where we have the location of the catalog microservice in the items API. So if I say continue, that's going to talk immediately to the catalog microservice. As you can see, now we are in the catalog microservice. Let me collapse this a bit. And here's where we're going to go ahead and talk to our to our repository to talk to the MongoDB database and then return the items. So I'll just say continue. And now we are back into the front end where we have received that response, which we can briefly inspect on the left side. Let me collapse this and that and that. And as you can see, we got a 200 status code, which is great. And then we need to convert that promise into the actual set of items. So for that, I'll just hit continue. And now we have our list of items over here in this returned items variable, where you can see we have collected the items from the server side with the date, the description, the ID, and the name as an array. And then if you just hit continue, then we go back to the browser, we can see that the items are right there. Now, how about creating a brand new item? So let's go ahead and click the add button here. And this is the form where you can go ahead and actually create an item. So again, how is this form working? So going back to play the front end, go to the code base, you're going to find the code for that under form, in item form, right here. If we go back up, there's a method called create item. So this is the one that's going to be in charge of sending the post request to the catalog microservice to create the item. And we can do the same exercise by just placing a breakpoint over here, and then we're going to get a response over there. Same way, we can go back to the catalog microservice and we can place a breakpoint into the post async method over here. Now back to the browser, let's go ahead and create an item. So let's say we're going to create, in this case, a shield. And let's call it actually bronze shield. And this is going to be a basic shield. Now, what happens if I just don't put a price here? So I'll go ahead and hit save. And you can see that this is going to happen. So we have enabled client-side validation via React into the client side. So here it is making sure that I have a name and that I have a price. If I don't have a price, then this happens. So sure enough, I can put a price and that should work. But before we do that, what happens if I do something a bit different, like putting an invalid price, like a -5? If you remember, the catalog microservice has been configured with validations and it should not allow a negative price here. I have intentionally not enabled client-side validation for a negative number here so that it just let it go. But how would that look like in the over here when the validation actually comes from the server side? To figure that out, I'll actually go back to front end and I'll put yet another breakpoint into the catch section over here. So now let's go back to the browser and try to save that. So now we are back into front end. So as you can see, we will send a request to the catalog items microservice. I'll hit continue. And as you can see, we already got a response here. We didn't even get to reach the controller on the microservice because the ASP.NET Core validation runtime verified that this is not an allowed thing. Like the DTO that we sent did not pass the validations. So as you can see, the response here is already telling us that this is a 400 bad request because we have sent an invalid value. And in fact, if you want to know more about what happened here, what we can do is just, let me put another breakpoint over here and I'll hit continue. And now we can inspect this error data section here. And it says here, yeah, one or more validation errors occurred, which by the way is the exact same validation that we were seeing before in Postman for this kind of invalid inputs. And if we expand the error section here, you can see that we have all the errors that are coming back from the microservice, like the field price must be between 0 and 1,000. So this is one way that if you wanted to, you can show that error with that specific error into the client. In our case, we are only showing the error data, that title property. That's as much information we want to show to the client at this point. So I'll just say continue. Then we reach the catch section, which will catch all the errors either from validations or for any other kind of communication errors from the client and the server. And that's going to show an alert. We say continue and then back to the client. This is what we're going to see. Could not add the item, one or more validation errors occurred. So to fix this, let's actually put a correct price. Let's say 6. Then I'll hit save. So back to front end, we'll send the fetch request. And now we hit the catalog microservice because the validation succeeded. So the controller is actually being hit now. So this will go ahead and, as you know, it will execute the logic to create the item and then publish that item into the message broker in RabbitMQ so that the other microservices can get notice of this. So I'll hit continue. Then we're back into the front end. And this time, if we expand the response, we can see that we got the expected 201. And then we hit continue and back into the browser, the item has been created. Bronze shield, basic shield with price 6. Okay, so what about editing an existing item? So to edit an item, all you have to do is click on the edit button here, and this will allow you to perform the edit. But before actually going through the edit scenario, let me actually just go ahead and remove all these breakpoints, since I think we get the idea now of how communication is flowing across places. So let me go to the breakpoints and just remove all of them over here and also in the catalog microservice. So I'm going to go ahead and remove all breakpoints. Okay, so now back to the front end. The edit logic is happening if we go back into in item form. So that is happening in the update adding method. So here's where again we call the fetch method with the URL of the REST API plus the ID of the current item. So that will go ahead, do the fetch operation, and then later we'll get a response over here. So let's see how that works in real life. Over here, I'm going to just bump the price from 6 to 8, and then I'll just hit save, and the edit has been performed. Notice how things never reload here, like the page is never really reloading. It's just a React component that's fetching the updated data and putting it dynamically into the same page that we're always working on. Then we can also try the delete scenario. And that happens if we go back into front end, that is happening directly into the catalog.js file. There is a section called delete item that's invoked by that red delete button. See, there's going to be a confirmation, then it invokes the catalog API with the ID of the item, and then it performs the delete, and also it removes it from the client state. So to see that in action, let's go back to the client. And then I'll actually like to keep this bronze shield and the other items. So what I'll do is I'll create quickly another one. Let's just call it delete me, delete description, and then I'll say price for, right? So I'll save this item is created. And for a delete operation, all you have to do is click on delete. There's going to be a delete confirmation box here. Click OK, and the item is gone. And you can always confirm that these are actually happening in the server side by refreshing the browser, and you can see that the items are actually gone. And of course, you can also take a look at the database. Now, how about granting an item to a user, which touches bases with the inventory side? So to do that, what you can do is use this grant button over here. So let's say I'm going to grant this bronze shield to a user. So I'll click on grant, and this pops up this model dialog to grant an item. Now in this dialog, what I have done is I have made it so that anytime you open it, it's going to populate some random GUID for some random user ID. Remember, we don't have the concept of the users really here, so it's just a random user ID. So just like we did a random user in Postman, now this page is presenting a random user ID, random GUID here. And also there's a quantity that you can increase or decrease as needed. Now this here is happening back in the front end, is happening in the grant item form JS file over here. Here is where we can actually do a breakpoint for this one. This is where we will invoke the inventory items API with the data that we have about this item, and then the inventory service is going to take care of granting the item to the user. So if you go back to the browser and we say, let's say we're going to grant 2 of the potion, actually 2 of the grant to the bronze shield to the user, I'll say grant. And then if you go back here in grant item form, we can see that the inventory items URL is going to be invoked. This time is 5005/items. And that is going to use the user ID that we specified in the client side, the catalog item ID, which is right here, and the quantity, which is 2. And just to not lose it, I'm actually going to grab this user ID. I'm going to copy this one so that we can query for it later. And then, yeah, I'll hit continue. And that would have granted the item to the user. Now, there's no visual representation of that completion in this page, but that's why we have this other page for inventory. So let's go to the inventory section over here. And here is where you can paste that user ID and you can get inventory for the user. Now, all the logic here is happening. If you go back to the front end, this is happening actually in the inventory.js page. So this is the page that is going to allow us to populate items based on this on the entered user ID. That's going to go ahead and talk to inventory API with that user ID, and that brings back all the items that are in the user's inventory pack, which is rendered over here in this section, render items table. So we go back to the browser, we'll just hit get inventory, and there you go. The current inventory for the user is presented. In this case, just a bronze shield. Now, once again, it's also interesting to see what happens if there's an update, if an update happens to this item, right? Would the UI be able to reflect the fact that inventory needs to have updated data from the catalog when that happens? Would that take too much time? How would that render? So let's see. So we have bronze shield, it's named bronze shield, basic shield, quantity 2. So let's go back to the catalog, and we're going to edit the bronze shield, and we're going to change the name. So instead of having it as bronze shield, we'll just call it basic shield, right? And perhaps we'll also update the price. Let's say it's 9. And so now the bronze shield is named basic shield. So I'll hit save. And I'll go back to inventory, and I'll query again for the items of this user that we just granted inventory to. So I'll hit get inventory, and as you can see, the name has changed to basic shield. That means that as soon as we performed the update in the catalog microservice, that was immediately replicated via an asynchronous message into the inventory service, and inventory is now able to present the updated name of the shield, in this case basic shield. And that happened really fast. So there you go. We have gone through all the sections in this basic front-end user interface. So that marks the end of this model, and you have connected a modern single-page application built with React and hosted in Node.js with your two .NET-based microservices to light up a basic end-to-end scenario. And you learned all about cores along the way. I hope you enjoyed building this system with me so far. In this model, you will learn all about the membership system built in to ASP.NET Core and how you can leverage it to stand up an identity microservice that can keep track of the different users that will interact with the play economy system. By the end of this model, you will have a solid understanding of the following. What is ASP.NET Core Identity and how you can enable it in your ASP.NET Core apps? An initial high-level view of the components to be added to our upcoming identity microservice. How to scaffold identity components into an ASP.NET Core app. How to integrate ASP.NET Core Identity and MongoDB. How to enable user registration and login in our identity microservice. And how to enable a REST API to manage the users stored in our identity database. Let's get started. In this lesson, we will learn about the need for a membership system to track the multiple aspects related to your microservices users, how ASP.NET Core Identity can help, and how to leverage it in our upcoming identity microservice. As you know, we have already introduced the concept of a user into the play economy system. Thanks to our inventory microservice, we can both grant catalog items and query for all the items in the user's inventory bag. However, at this point, we don't know much about this user other than the user ID. If we get on the shoes of our users or players for a moment, we will realize that there are a bunch of things that we would like to know or do in the system, but we are not able to do yet. For instance, as a player, to acquire catalog items into my inventory, I will need to pay for them first. However, I still don't know how much yield I have available or where this is stored. If my yield is stored somewhere in the play economy system, I would like to know how to access the system, and in fact, how do I become part of the system to start with? Then, as I register in the system, I'd like to know if my personal data is protected, especially things like my sign-in credentials. Is a combination of username and password enough to enter the system, or can additional layers of protection be put in place? Also, after I sign in into the system, what can I actually do there? Can I see or modify the inventory of other players? Can I happily grant 1 million yield to my own account to go and purchase items almost without limits? There should probably be some boundaries in there. As you may realize by now, we need a system to take care of all of this. Specifically, a membership system. Luckily, there is a membership system already baked into the .NET platform, and it's called ASP.NET Core Identity. This membership system brings in APIs to perform all the basic user management tasks, such as registering a new user, getting the list of registered users, and updating or deleting existing users. This includes APIs to send an email confirmation after the user registers and to perform the password recovery process. There are also APIs to sign in and sign out users and to manage the different roles you may want to enable in your application. For instance, in our system, you may want to separate our players, which can only perform a few limited actions, from our administrators, which can perform all sorts of management-related tasks across the whole system. A great feature of ASP.NET Core Identity is the fact that it includes pre-built UI functionality for user registration, login, logout, and personal data management. You can take advantage of these UI pieces as is, or you can also customize all or part of it as you see fit for your application. You can also enable more advanced features like multi-factor authentication, or perhaps you would prefer to delegate the authentication piece to external login providers like Facebook, Twitter, Microsoft, or Google. Finally, you can also store the additional claims and access tokens from these external authentication providers into ASP.NET Core Identity to offer more advanced identity-related scenarios within your app. Let's now see how ASP.NET Core Identity fits into our Play Economy system. To introduce all these identity-related capabilities to our system, we will stand up a brand new microservice called Identity. This microservice will be directly integrated with ASP.NET Core Identity to enable all the user and role management capabilities needed in our system. Let's take a quick look at the initial implementation of this new service. ASP.NET Core Identity includes a UI library based on the Razor Pages framework. We will take advantage of these UI components to enable user registration and sign in. That way, we don't have to invent the wheel around these basic UI scenarios. We will then implement a REST API for user management in a similar way to how we implemented REST APIs in our other microservices. That way, we can have operations to get the details of our users, to update details like the amount of yield assigned to a user, and also to enable user deletion. The good thing is that this time we don't have to implement a repository or any piece of code to interact with a database. ASP.NET Core Identity includes a series of classes called managers that allow you to easily interact with the different components of the membership system. For instance, you can use the user manager to perform all the usual CRUD operations involving our users, the role manager for all operations involving roles, and the sign-in manager to perform user sign-in, sign-out, and a few other operations. These identity managers interact with what we call identity stores, which are concrete data access implementations to interact with a specific data store provider. ASP.NET Core Identity comes with built-in stores based on the Entity Framework Core Object Relational Mapper, which by default is configured to store data in a SQL Server database. We could certainly use this default implementation, but since we are already using MongoDB as our database server in our previous microservices, we will use a MongoDB-based stores implementation instead. All the identity managers will be configured to use these MongoDB stores to persist users and roles to a new MongoDB database owned by the identity microservice, therefore avoiding the need to bring in SQL Server into the picture. Now, in terms of what actually needs to get implemented, we will use most of the built-in Razor pages as is, but we will need to add a few modifications to the page used for user registration, just so that we can set an initial amount of yield for each new player. Implementing the user's REST API is also all on us, since that is not available by default in ASP.NET Core Identity. Although the actual implementation is very straightforward, since all the identity managers are already built in and they are generalized in such a way that the REST API does not need to know which is a specific configured identity store. Also, we won't need to implement the MongoDB stores, since there are multiple NuGet packages publicly available that can do this job for us. So we will just pick the one that works best for our needs and configure it in our microservice. Let's go ahead and create our identity microservice.